The velvet curtain of night has always been our sanctuary. For billions of years, the rhythms of life on Earth have been dictated by a simple binary truth. The sun rises and the sun sets. We have evolved to rely on the darkness. It is in the shadows that we rest, that our biology repairs itself, and that we look up to witness the infinite tapestry of the cosmos. We assume this cycle is eternal. We assume that the concept of day belongs to a single star, our soul, a lonely yellow dwarf drifting through the Orion arm of the Milky Way. But the universe is not obligated to respect our assumptions. In fact, when we look at the broader neighborhood of our galaxy, we realize that single star systems are not the only standard. Many stars have companions. They dance in pairs, binary systems where two suns trace burning ellipses around a common center of gravity. We consider ourselves lucky to have a single, stable parent star. But hanging in the darkness, roughly 444 million miles away from us, sits a sleeping giant. A world that is often called a failed star. It is the king of planets, Jupiter, a colossus of swirling gas and ancient storms, holding more than twice the mass of all the other planets in our solar system combined. It sits there, a silent sentinel, watching over us from the cold reaches of the outer solar system. But what if it woke up? What if the failed star was given a second chance? What if, through some cosmic injection of mass or a sudden collapse of physics as we know it, the nuclear fires in its heart were finally ignited? Imagine looking up at the night sky, expecting to see the familiar comfort of the moon and the faint constellations, only to find the darkness torn apart by a crimson glare. Imagine a second sunrise, not from the east, but from the location of the wandering planet. This is not just a fantasy of science fiction. It is a question of physics, of mass, and of the delicate balance that holds our fragile world together. Today, we are going to ignite the king. We are going to turn Jupiter into a star and watch as our solar system is transformed forever. Hello, my fellow travelers of the night. I am Theodore, the researcher. Together, we walk the line between the known and the impossible, asking the questions that keep the mind awake long after the lights have gone out. If you enjoy wandering through these corridors of cosmic possibility, if you find peace in the vastness of the hypothetical, please take a moment to subscribe to this channel and join our community of curious souls. Your presence here helps us continue this journey, turning the cold equations of astrophysics into stories that warm the imagination. Thank you for being here. Now, let us turn our gaze outward, past the asteroid belt, to the sleeping giant that is about to open its fiery eye. To understand what would happen if Jupiter became a star, we must first understand what Jupiter is, right now. It is easy to think of it merely as a big planet, but that description fails to capture its true nature. Jupiter is a beast of hydrogen and helium, the very same primordial elements that make up our sun. In fact, if you were to take a sample of the Jovian atmosphere, you would find it is roughly 75% hydrogen and 24% helium by mass, with a sprinkling of heavier elements like methane, ammonia, and water. This composition is strikingly similar to the sun itself. This is why astronomers sometimes refer to Jupiter as a failed star. It has the right ingredients. It has the gaseous nature. It even emits more heat than it receives from the sun, generating warmth from the slow, crushing gravitational contraction of its own massive body. But it lacks the one thing that separates the planets from the stars: sufficient mass. Mass is the currency of the cosmos. In the stellar economy, mass dictates destiny. Our sun is a star because it is massive enough, about 333,000 times the mass of Earth, to generate immense pressure at its core. This pressure creates temperatures exceeding 27 million degrees Fahrenheit, forcing hydrogen atoms to smash together and fuse into helium. This process, nuclear fusion, releases the blinding energy that bathes our solar system in light. Jupiter, for all its terrifying size, falls short. It is massive, yes, 318 times the mass of Earth, but it is still only about 0.1% of the mass of the Sun. To a human, Jupiter is a god. To the universe, it is a speck of dust that never quite caught fire. The pressure in Jupiter's core is intense, enough to turn hydrogen into a strange metallic liquid that conducts electricity, generating the planet's powerful magnetic field. But it is not hot enough, nor dense enough, to ignite the proton-proton chain reaction that powers a star. So, let us begin our experiment. To turn Jupiter into a star, we cannot simply light a match. We must fundamentally change the architecture of the solar system. We need to feed the giant. According to our current understanding of stellar physics, the boundary between a large gas giant and a small star, a red dwarf, lies at approximately 75 to 80 times the mass of Jupiter. There is a middle ground, a strange class of objects called brown dwarfs, which sit between 13 and 80 Jupiter masses. These substellar objects can fuse deuterium, a heavy isotope of hydrogen, for a brief period, glowing with a dull magenta heat. But we want a true star. We want a second sun. So, in our scenario, we must magically add roughly 80 times the current mass of Jupiter to the planet. Imagine thousands of other gas giants, harvested from across the galaxy, pouring into the Jovian gravity well. As this mass accumulates, something terrifying and beautiful begins to happen. Gravity, that patient sculptor of the cosmos, begins to squeeze the heart of the planet with a force that defies comprehension. The radius of the planet would not necessarily grow larger. In fact, as we add mass, the gravity becomes so strong that it might actually compress the planet further, making it denser. The core temperature begins to spike. It rises from a mere 43,000 degrees Fahrenheit to millions. The hydrogen atoms, which have spent billions of years bumping against each other in the dark, are suddenly stripped of their electrons. They become a plasma. And then, in a moment of cosmic alchemy, the first true fusion event occurs. Two protons slam together, overcoming the electromagnetic force that tries to push them apart, and they fuse. Energy is released. A photon is born in the crushing dark of the core. This energy pushes outward, fighting against the inward pull of gravity. The object enters a state of hydrostatic equilibrium. It is no longer a planet. It is no longer a collection of gas held together by cold gravity. It is a living, breathing engine of nuclear fire. Jupiter has ignited. But this new star would not look like our sun. It would be a red dwarf, an M-class star. These are the most common stars in the universe, small, cool, and dim compared to our yellow G-class sun. Its surface temperature would be around 5,000 to 6,000 degrees Fahrenheit, radiating a light that is not white or yellow, but a deep, glowing crimson. From the surface of Earth, 144 million miles away, the transformation would be spectacular. Currently, Jupiter is one of the brightest objects in our night sky, a brilliant white point of light that outshines the stars. But as it ignites, that point of light would intensify 1,000-fold. It would not rival the sun. Our sun is still 1,000 times more luminous than a red dwarf, but it would become something entirely new. It would cease to be a star in the visual sense and become a small, resolved disk in the sky. A red eye glaring down at us from the zodiac. At its closest approach to Earth, roughly 365 million miles away, this new red Jupiter would shine with a brightness that casts distinct shadows. It would be hundreds of times brighter than the full moon. Imagine the psychological impact of this first night. You watch the sun set in the west, the sky fading into twilight. But as the blues of dusk deepen, the eastern horizon begins to glow with an eerie, bloody light. The shadows of the trees lengthen, but they are strange, double shadows, one sharp and black from the fading sun, and one soft and red from the rising Jupiter. The night never truly comes. Instead, the world is bathed in a perpetual, dim crimson twilight. The constellations are washed out, drowned in the pollution of this new stellar light. The Milky Way, that river of souls that our ancestors worshipped, disappears behind a veil of red. We would lose the deep dark. We would lose the window to the wider universe. But the visual change is just the beginning. The birth of a star is a violent event, and our solar system is a delicate clockwork mechanism. By adding 80 times the mass of Jupiter to the solar system, we have fundamentally altered the gravitational balance of our neighborhood. Every planet, every asteroid, every comet feels the tug of this new anchor. The Earth, which has spent eons tracing a stable ellipse around the sun, suddenly feels a new hand pulling at it. We are caught in a tug of war between two masters. The sun, our original parent, still holds the dominant grip, possessing 99% of the solar system's mass, even with the new Jupiter. But the new Jupiter is now massive enough to perturb our orbit. The consequences of this gravitational shift would not be immediate destruction, but a slow, chaotic unraveling of stability. We often think of the solar system as a model of perfection, planets moving on rails. But chaos theory tells us that even small changes in initial conditions can lead to wildly unpredictable results over time. With a second star of this mass, the circular orbits of the planets would begin to stretch. They would become more eccentric, more oval-shaped. For Earth, this means that our distance from the sun would start to vary more drastically throughout the year. We might be pulled closer to the sun's searing heat during one part of the year, and then flung further out into the freezing void during another. And then there is the radiation. A red dwarf is not a gentle neighbor. While they are cooler than the sun, they are known for being magnetically volatile. They are prone to violent stellar flares, bursts of X-rays and ultraviolet radiation that can strip atmospheres from planets. Our new Jupiter would be young, rotating rapidly, and thrashing with magnetic energy. It would blast the solar system with winds of charged particles. The Earth's magnetic field, our invisible shield that protects us from the sun, would now be assaulted from two directions. Would it hold? Or would the combined solar wind of two stars compress our magnetosphere until the auroras, the northern and southern lights, moved from the poles to the equator, painting the entire globe in curtains of green and violet fire? It is a beautiful image, isn't it? A world of two suns, of red nights and auroral storms. But beauty in the cosmos often comes with a price. As we stand here on our hypothetical Earth, basking in the crimson glow of the new star, we must ask ourselves, what happens to the delicate balance of life? Biology is tuned to the rhythm of 24 hours. Our plants rely on a specific spectrum of light for photosynthesis. Our oceans rely on the moon for tides. But now, they would feel the gravitational heave of a second massive body, The tides would grow wilder, the weather would grow stranger. The peace of our single-star existence is over. We have entered the era of the binary system. This thought experiment invites us to consider how fragile our normal really is. We take the stability of our orbit for granted. We take the darkness of the night for granted. We assume that the planets will stay in their lanes and the sun will stay in its place. But the universe is dynamic. It is a place of violent change and transformation. By imagining Jupiter as a star, we are forced to appreciate the specific, rare conditions that allow us to exist. We realize that we live in a Goldilocks zone, not just of distance, but of gravitational architecture. We are lucky that Jupiter failed. We are lucky that it remained a gas giant, acting as a shield that absorbs comet impacts, rather than a second furnace that cooks us with radiation. As the new red Jupiter rises higher in our simulated sky, casting its bloody light over the oceans, we can almost hear the gravitational groan of the solar system adjusting to its new reality. The asteroids in the belt between Mars and Jupiter are the first to feel the chaos. They are scattered like leaves in a storm, flung inward toward the inner planets, or ejected outward into the void. The sky above us becomes a shooting gallery. The peace of the night is replaced by the anxiety of the new dynamic. But in this anxiety, there is also wonder. We are witnessing the power of mass. We are witnessing the conversion of potential energy into starlight. We are seeing the universe rewrite the rules of our home. In the chapters that follow, we will journey deeper into this terrifying and magnificent scenario. We will explore the fate of the moons of Jupiter, Europa, Ganymede, Callisto, which are no longer icy satellites, but charred worlds orbiting a star. We will calculate the new temperature of Earth. We will look at the long-term stability of the solar system and ask if humanity could survive on a planet with two shadows. But for now, let us simply stand on the beach of our imagination, feeling the cool breeze of the evening and watching as the single bright dot of Jupiter expands, brightens, and ignites, turning the black ocean into a sea of red wine. The king has awakened, and nothing will ever be the same again. This is the beginning of our journey into the binary solar system. It is a journey of physics, of biology, and of the imagination. We will tread carefully, for the forces we are playing with are enough to tear worlds apart. But we will also look for the beauty in the chaos, for that is what we do. We search for the light. Even when it comes from a source we learn to fear. The immediate aftermath of a stellar birth is not a time of peace. It is a time of incineration. When we imagine the ignition of Jupiter, our minds naturally drift to the view from Earth, to the spectacle of a second sun hanging in our sky. But for the celestial bodies that have spent billions of years orbiting the gas giant, the transformation is not merely a change of scenery. It is an apocalypse. We must turn our gaze to the Galilean moons, Io, Europa, Ganymede, and Callisto. These four worlds, discovered by Galileo Galilei more than 4 centuries ago, have long been the jewels of the outer solar system. They are diverse, complex worlds of ice and fire, existing in a delicate equilibrium with their massive parent. But in our scenario, that parent has just become a star. The gravitational hierarchy remains, but the thermal reality has been shattered. The mini-solar system that is the Jovian system has just become a solar system in its own right, but it is a system born in violence. Consider the tragedy of proximity. In the universe, distance is safety. The Earth sits a comfortable 93 million miles from the Sun, a distance that allows for liquid water and gentle breezes. The moons of Jupiter do not have this luxury. They orbit at distances that are, in cosmic terms, intimate. Io, the innermost of the large moons, circles Jupiter at a distance of roughly 262,000 miles. This is roughly the same distance as our moon is from Earth. Imagine if our moon were suddenly replaced by a red dwarf star. The consequences for Io are instantaneous and catastrophic. Io is already the most volcanically active body in the solar system, tortured by the immense gravitational tides of Jupiter. But now, it is orbiting inside the corona of a star. Hello again, explorers of the impossible. I am Theodore, the researcher, and we are continuing our thought experiment into the terrifying majesty of a binary solar system. We are standing witness to the death of the old worlds and the birth of a new, fiery order. If you find value in these deep dives into cosmic hypothetical scenarios, if you want to support this channel and ensure we can keep asking, what if? Please take a moment to subscribe. It is a small gesture, but it means the world to us. Thank you. Now, let us return to the inferno that was once the Jovian system. As Jupiter ignites, its surface temperature leaps from a frigid minus 234 degrees Fahrenheit to a searing 5,000 degrees Fahrenheit. The radiation pressure alone would hit Io like a physical hammer. The tenuous atmosphere of sulfur dioxide that currently clings to Io would be stripped away in seconds, blasted into space by the stellar wind of the new star. But the surface itself would not survive long enough to mourn the atmosphere. The intense heat, radiating from a source that fills nearly half the sky, would flash melt the rocky surface. Io would cease to be a solid moon. It would become a droplet of magma, a sphere of molten rock, trailing a tail of vaporized stone as it screams around its orbit. It would look less like a moon and more like a comet made of lava, slowly evaporating into the stellar fire. It is a violent end for a tortured world, returning its matter to the star that consumed it. Moving outward, we reach Europa. This is perhaps the greatest loss in our scenario. For decades, scientists have looked at Europa with hope. Beneath its cracked, icy shell lies a global ocean of liquid water, containing twice as much water as all of Earth's oceans combined. It is considered one of the most likely places to find extraterrestrial life in our solar system. Microbial life could be swimming in that dark, salty abyss right now, huddled around hydrothermal vents, protected from the cold of space by the miles-thick crust of ice. But when Jupiter becomes a star, that protection vanishes. The ignition of the red dwarf would hit Europa with a wave of thermal energy that defies description. At first, one might think that the heat would simply melt the ice, creating a paradise, a true water world. And perhaps, for a fleeting, tragic moment, that is true. As the temperature rises, the ice shell would fracture and groan. Massive geysers of steam would erupt, not just from cracks, but from the entire surface. The ice would turn to water. The global ocean would be exposed to the sky. But the heat would not stop there. Europa orbits only 417,000 miles from Jupiter. It is far too close. The new star would boil the ocean. The water would turn to superheated steam, creating a thick, choking atmosphere that would trap even more heat. The greenhouse effect would run away instantly. Europa would transition from an ice world to a steam world. And finally, as the water molecules were broken apart by ultraviolet radiation, it would become a dry, scorched rock. Any life that existed in the deep dark would be boiled alive in its own home. The tragedy of Europa is the tragedy of bad timing. Just as it received the energy it needed to thaw, it received too much, too fast. Then there is Ganymede, the largest moon in the solar system. It is bigger than the planet Mercury. Under normal circumstances, Ganymede is a frozen wasteland of rock and ice. But in the light of the new red Jupiter, Ganymede might actually find itself in a strange, transient Goldilocks zone. Because the new star is a dim red dwarf, its habitable zone, the region where liquid water can exist on the surface, would be much closer than the Sun's. Ganymede, orbiting at 665,000 miles, might sit right on the edge of this zone. As the ice on its surface melts, it might form a deep global ocean that does not immediately boil away. Imagine standing on the surface of a transformed Ganymede. The sky is dominated by the massive crimson disk of the sun that was Jupiter. The ice beneath your feet has turned to a slushy, churning sea. The air is thick with water vapor. For a few million years, before the radiation strips the atmosphere away, or the tidal forces tear the moon apart, Ganymede might be a habitable world, a blue marble orbiting a red eye. It is a haunting image, a second Earth, born from the ashes of a frozen moon, orbiting a star that shouldn't exist. But let us step back and look at the mechanics of this new system. We have created a binary star system, yes, but it is an unequal partnership. Our original sun is a G-type main sequence star, massive and bright. Our new red Jupiter is an M-type dwarf, small and dim. This configuration is actually quite common in the galaxy, but usually the two stars orbit each other at a great distance, or they orbit a common center of gravity in empty space. Here, the red Jupiter is orbiting the sun. This creates a fascinating dynamic for the moons that have now become planets. You see, in a technical sense, the Galilean moons are no longer moons. They are planets orbiting a star, which in turn orbits another star. They are worlds caught in a gravitational hierarchy that is dizzyingly complex. From the surface of Ganymede, the day-night cycle would be a chaotic mess. The primary source of light and heat is the red Jupiter, which hangs fixed in the sky because Ganymede is tidally locked. It keeps one face toward its parent at all times. So, one side of Ganymede is baked in perpetual red noon, while the other side faces away into the dark. However, the dark side is not truly dark. Every few days the original sun would rise, blasting the night side with brilliant white light. There would be no true night on Ganymede. There would be the red day on one side and the white day on the other, with a twilight zone in between where the shadows of two suns dance and merge. This lack of darkness would have profound implications for any chemistry trying to organize into life. There is no rest. There is no cooling cycle. There is only the relentless pouring of photons from two different nuclear furnaces. And we must not forget the magnetic violence. Red dwarf stars are notorious for their temper tantrums. They are covered in star spots and prone to unleashing flares that can double their brightness in minutes. Our sun flares too, but its mass dampens the effect. The red Jupiter, being small and fully convective, meaning the plasma circulates from the core to the surface and back, is a magnetic dynamo. It would whip the space around it with magnetic field lines that snap and reconnect, accelerating particles to near light speed. The radiation belts around Jupiter are already deadly to human electronics and biology. Around a stellar Jupiter, these belts would expand into a torus of death millions of miles wide. The auroras on the Galilean worlds would not be gentle curtains of light. They would be blinding, continuous storms of electricity that would fry any atmosphere that tried to form. The habitable Ganymede, we imagined, might effectively be a microwave oven sterilized by the invisible fury of its parent star. The transformation of the Jovian system teaches us about the fragility of definitions. We draw lines between planet and star, between moon and world, but nature sees only a continuum of mass and energy. By adding mass to Jupiter, we have slid it along that continuum, and in doing so, we have erased the unique environments that made the Jovian system so special. We have traded the possibility of life in Europa's hidden ocean for the certainty of destruction on its surface. We have traded the majestic striped beauty of the gas giant for the generic glare of a red dwarf. It is a reminder that more energy is not always better. Sometimes the cold, dark quiet is exactly what is needed to nurture the delicate spark of complexity. As we leave the immediate neighborhood of the new star, escaping the radiation hellscape that was once a system of ice moons, we must turn our sensors back toward the inner solar system, back toward the blue dot that is watching this catastrophe from a distance. The light from the new star has now reached Earth. The gravitational waves are rippling through the fabric of space-time, tugging at our planet. The orbit of Earth is beginning to shift. The question is no longer about the fate of Europa or Ganymede. They are gone, casualties of the ignition. The question now is about us. Can Earth survive in a system with two suns? Or is our biosphere, so perfectly tuned to the singular rhythm of Sol, about to be unraveled by the chaotic interference of the Red King? The night sky of Earth has changed forever. The constellations of the zodiac, the path that the planets follow, is now dominated by the red glare. Ancient astrologers would have gone mad trying to interpret this omen. Modern astronomers are likely in a panic, running simulations that show our orbit becoming unstable. The gentle ellipse that has cradled life for 4 billion years is being pulled into something new, something jagged and unpredictable. The seasons, once dictated by the axial tilt of our planet, are now subject to the distance from the second heater in the sky. We are drifting into uncharted waters. The physics of three-body problems, the Sun, the Earth, and the red Jupiter, are notoriously difficult to solve. There is no simple equation that predicts the future of such a system. There is only the chaotic dance of gravity, where a small nudge today can lead to ejection from the solar system 1 million years from now. In the next chapter, we will land on this altered Earth. We will walk through the forests that are confused by the red light. We will stand on the shores of oceans that are being pulled by conflicting tides. And we will ask the ultimate question. If the solar system is a machine, what happens when you add a second engine that spins in a different direction? The beauty of the cosmos is often found in its terror. The destruction of the Galilean moons is a tragedy, yes, but it is also a display of the raw power that governs the universe. Matter is neither created nor destroyed, only transformed. The ice of Europa becomes the steam of a new atmosphere. The rock of Io becomes the plasma of a new star. It is a cycle of majestic violence that has been playing out since the Big Bang. We are just lucky enough, or perhaps unlucky enough in this story, to be watching it happen from the front row. So, take a deep breath. The air is still breathable for now. The sun still rises in the east for now. But in the west, the red eye is watching, and it is getting brighter. The sky we were born under is a memory. That is the first thing we must accept as we stand on the surface of this altered earth. For the entirety of human history, and for eons before our species climbed down from the trees, the night was a time of absence. It was the negative space of existence, defined by what was not there, the sun. It was a time of cold, of rest, and of the faint, distant glittering of stars that were too far away to touch us. But now, the definition of night has been rewritten by the laws of astrophysics. As the Earth rotates away from our primary sun, plunging the continents into what should be darkness, we are greeted not by blackness, but by a twilight that refuses to end. The red Jupiter, now a fully ignited dwarf star, hangs in the sky like a persistent, bloody eye. It does not provide the cheerful, golden warmth of the sun. Its light is different. It is a deep, somber crimson, a wavelength that sits heavy on the human psyche. It paints the world in monochrome, the vibrant greens of the forests, the blues of the oceans, the colors of our cities, all are washed out, replaced by shades of rust and dried blood. The shadows are strange, too. They are not the sharp, distinct silhouettes cast by the sun. They are soft, diffused, and they stretch in the wrong directions, creating a visual dissonance that makes the familiar world feel like a dreamscape or a hallucination. This new light is bright enough to read by. It is bright enough to cast a shadow that rivals the full moon 100 times over. It is bright enough to extinguish the stars. When we look up, we no longer see the Milky Way. We no longer see the faint fuzz of the Andromeda Galaxy or the glittering nursery of the Orion Nebula. The cosmic tapestry has been erased, washed away by the light pollution of our own making. We have traded the infinite depth of the universe for a local lamp that never turns off. The astronomers are the first to mourn. Their telescopes, designed to peer into the deepest dark, are now blinded for half the year, overwhelmed by the glare of the Red King. We have become visually isolated, trapped in a bubble of red light, cut off from the grander context of the cosmos, just as we were beginning to understand it. Hello, my friends. I am Theodore, the researcher. We are walking through the simulation of a binary solar system, exploring the consequences of waking a sleeping giant. It is a journey that takes us from the cold equations of gravity to the warm, messy reality of biology and human emotion. If you are finding a strange comfort in these stories of cosmic transformation, if you enjoy exploring the boundaries of what is possible, please consider subscribing to this channel. Your support allows us to continue building these worlds one atom at a time. Thank you for walking this path with me. Now, let us look down from the sky and see what this new light is doing to the life that crawls upon the earth. Biology is a slave to rhythm. Every living thing on this planet, from the single-celled algae floating in the Pacific to the great redwood trees of California, has a clock ticking inside it. This is the circadian rhythm, a biological feedback loop tuned precisely to the 24-hour cycle of light and dark. It tells flowers when to open and close. It tells nocturnal predators when to hunt. It tells the human body when to release melatonin, the hormone that allows us to sleep and repair our minds. But what happens when the trigger for that clock, the darkness, disappears? The confusion begins in the plant kingdom. The forests of Earth are suddenly bathed in a spectrum of light. They were not evolved to process continuously. While the red Jupiter is far dimmer than the sun, its light is constant during the Jovian season. Plants that require a period of darkness to respire, to absorb oxygen and break down sugars, find themselves in a state of metabolic stress. They are being pushed to work a double shift. Some species might thrive, growing wild and fast in the perpetual twilight, choking out the delicate flora that needs rest. We might see a transformation of our green planet into a world of aggressive, fast-growing weeds, a botanical chaos driven by the excess photons. For the animal kingdom, the impact is even more immediate. Consider the nocturnal hunters, the owls, the bats, the big cats. They rely on the cloak of darkness to stalk their prey. In the red glare of the new star, they are exposed. Their camouflage is useless. The balance between predator and prey is overturned. Small mammals that scurry in the night would stay hidden in their burrows, too terrified to emerge into the exposed landscape. This would lead to starvation on a massive scale. The food web, a delicate tapestry woven over millions of years, would begin to fray. And then there are the insects. Moths, beetles, and other creatures that navigate by the light of the moon would be hopelessly confused, spiraling endlessly toward the red glare, unable to find their way. The pollination cycles of crops would falter. The silence of the night, usually filled with the chirping of crickets, might truly become silent as the confusion takes hold. And what of us? What of the human animal? We are adaptable, yes. We have electric lights and blackout curtains. We can simulate darkness in our homes, but we cannot escape the psychological weight of the red night. There is a deep, primal part of the human brain that fears the wrongness of the sky. We would likely see a rise in global insomnia, a collective restlessness as our bodies fight against the light. Culturally, the impact would be profound. Religions would rise and fall based on the interpretation of the new star. Some would see it as a savior, a second watcher. Others would see it as a demon, a bloodshot eye of judgment. The romanticism of the night, the moonlit walks, the stargazing, the feeling of solitude would be gone, replaced by an eerie, exposed feeling. We would never feel truly alone, never truly hidden. The red Jupiter would always be there, watching. But light is not the only invisible hand reaching out from the new star. We must talk about gravity. Gravity is the silent ruler of the universe, and we have just introduced a new heavyweight to our solar system. The mass of the new Jupiter is 80 times that of the old planet. While this is still small compared to the Sun, it is massive enough to shift the center of gravity of the entire solar system. Currently, the barycenter, the point around which the Sun and planets orbit, sits just above the surface of the Sun. With the new, massive Jupiter, the barycenter would be pulled further out into space. The Sun itself would begin to wobble more noticeably, tracing a wider circle as it dances with its new partner. For Earth, the gravitational consequences are subtle at first, but relentless. We are caught in a rhythmic tug-of-war. Every 13 months, as Earth passes between the Sun and the red Jupiter, we would feel the maximum pull. These are the opposition months, where the red Jupiter is closest to us. The tides of our oceans would respond to this new master. We are used to the gentle pull of the moon and the Sun creating our high and low tides. But the red Jupiter, despite its distance, is now massive enough to add a third component to the tidal equation. The Jovian tides would not be as strong as the lunar tides, but they would be significant. During alignment events, when the Sun, Earth, Moon, and red Jupiter line up, a super syzygy, the tides could be catastrophic. We might see coastal flooding on a scale never before experienced, with high tides surging meters above the normal limit, swallowing cities and reshaping coastlines. The rhythm of the ocean would become more chaotic, a complex interference pattern of 3 different gravitational sources. However, the most terrifying threat comes not from the water, but from the rocks. Between the orbit of Mars and the orbit of Jupiter lies the asteroid belt. This is a graveyard of rocky debris, remnants of a planet that never formed. For billions of years, the gravity of the original Jupiter has acted as a shepherd, keeping these rocks in check, nudging them into stable orbits, or ejecting them from the solar system. It has been a protector of the inner planets. But now the shepherd has become a wolf. The sudden increase in Jupiter's mass would send a gravitational shock wave through the asteroid belt. The delicate resonance that keeps millions of rocks in stable orbits would be shattered. Imagine a billiard table where the balls have been sitting still for eons. Suddenly, someone tilts the table. The asteroids would begin to drift. Their orbits would stretch and cross. Millions of rocks, ranging from the size of pebbles to the size of mountains, would be destabilized. Many would be flung outward, lost to the deep cold. But a significant number would be flung inward, toward the heat, toward the sun, and toward us. The inner solar system would become a shooting gallery. We would enter a new era of bombardment, a second late, heavy bombardment. The night sky, already polluted by the red light, would be streaked with the fire of meteors. Most would burn up in the atmosphere, providing a terrifying pyrotechnic display. But the big ones, the city killers, the dinosaur enders, would be out there, silent and dark, tumbling on new, unpredictable paths. We would be forced to watch the sky not for wonder, but for survival. Our space agencies would have to pivot entirely to planetary defense, tracking thousands of new threats that could arrive with little warning. This is the hidden cost of our second sun. We often think of more energy as a gift, a source of power and life. But in a system built on balance, more energy is chaos. The stability of the solar system is a happy accident of history, a settled peace after the violence of formation. By igniting Jupiter, we have unsettled the peace. We have kicked the hornet's nest. The rocks are moving. The water is rising. The plants are confusing day for night. And the humans are standing on their porches, bathed in red light, wondering if the warm glow on the horizon is a dawn or a fire. Yet, amidst the anxiety, there is a strange, terrible beauty to this new world. Imagine standing on a cliff edge overlooking the ocean during the red twilight. The waves below are churning with an unusual ferocity, driven by the complex tides. The sky above is a gradient of colors we have no names for. Deep purples where the red light mixes with the scattering blue atmosphere, fading into a bruised black at the zenith. The air feels charged, electric. You are witnessing a planet in transition. You are living through a moment of cosmic engineering that usually takes millions of years, compressed into a single lifetime. It is a reminder that the Earth is not a static stage for our human drama. It is a raft floating on a violent sea of forces. We are small, fragile passengers. As the weeks turn into months, the red Jupiter moves across the sky against the background of stars it has rendered invisible. It traces a path through the zodiac, a new god demanding tribute. The seasons on Earth begin to drift. The extra heat reaching our planet is not insignificant. While the red Jupiter is dim compared to the sun, it is still pumping energy into our atmosphere. It acts as a second heater, running in the background. It warms the nights. It prevents the poles from cooling down as much as they should during their winter. The delicate thermal engine of Earth's climate, driven by the temperature difference between the equator and the poles, begins to stutter. The jet streams, those rivers of air high in the atmosphere that steer our weather systems, would start to wobble and shift. We are just beginning to see the climatic consequences. The biological confusion and the tidal shifts are the opening acts. The main event is the slow, inexorable heating of our world. In the next chapter, we will watch as the ice caps react to a sun that never sets, We will see the weather patterns of Earth transform into something unrecognizable. Super hurricanes driven by double the energy, droughts that last for decades, and the transformation of fertile lands into deserts. We will ask if our civilization, built on the assumption of a stable climate, can weather the storm of the binary stars. The red light on your skin feels warm, almost gentle, like the heat of a dying ember. But do not be fooled. It is the heat of change, and change on a planetary scale is rarely gentle. It is a force that breaks the old to make way for the new. We are the old, and we are watching the new world rise in the east, red and hungry. We linger here for a moment in the uneasy quiet of the red night. Listen to the wind. It sounds different now, doesn't it? It carries the weight of a thicker, warmer air. It carries the sound of an ocean that is restless. It carries the whisper of a future that is rushing toward us at the speed of light. The simulation continues. The variables are updating, and the Earth is spinning into a future where the darkness is a luxury we can no longer afford. We often speak of the weather as a topic of small talk. We ask if it will rain tomorrow, if we should bring a jacket, or if the weekend will be sunny. We treat the atmosphere as a backdrop to our lives, a minor inconvenience or a pleasant surprise. But the atmosphere is not a backdrop. It is a heat engine. It is a colossal machine powered by the differential heating of the solar surface, driving the movement of air and water in a ceaseless quest to reach equilibrium. For all of human history, that engine has had a single fuel source, the sun. The energy budget of our planet was a simple ledger. Energy comes in from the day side, and energy bleeds out into the vacuum from the night side. The balance between these two numbers determines the temperature of our world. It determines the height of the oceans and the extent of the ice. But now, the ledger has been corrupted. We have added a second line item to the income column. The red Jupiter, burning with the dull, furious heat of a newborn star, is pumping energy into our system from the dark side. The engine of the atmosphere is revving up. It is taking in more fuel than it was designed to handle, and like any machine pushed beyond its specifications, it is beginning to shake, to rattle, and to break. The first casualty of this thermal injection is the ice. The polar caps of Earth, Antarctica in the south, and the sea ice of the Arctic in the north, act as the planet's air conditioners. They are vast mirrors made of frozen water, reflecting sunlight back into space. This is the albedo effect, a crucial mechanism that keeps our planet cool. Under the light of our original sun, white ice reflects heat. But under the crimson glare of the red Jupiter, the physics of reflection changes subtly. The red wavelengths are absorbed differently by snow and ice, especially as the ice begins to melt and form pools of dark water. But the bigger problem is the timing. In the Arctic winter, the sun does not rise for months. It is a time of deep freeze, allowing the ice to thicken and recover from the summer melt. In our binary system, the Arctic winter is no longer dark. For half of that season, the red Jupiter hangs in the sky, a heat lamp that refuses to turn off. The temperature never drops low enough for the ice to reform properly. Hello, travelers of the shifting wind. I am Theodore, the researcher. We are standing in the eye of a storm that spans an entire planet. We are watching the gears of Earth's climate grind against the friction of a new star. If these explorations into the fragility of our world resonate with you, if you find a strange peace in understanding the forces that shape our reality, please subscribe to this channel. Join our community of watchers. Your presence here is what keeps this journey alive. Thank you. Now, wrap your coat tight. The wind is picking up, and it is bringing a heat that does not belong here. Imagine standing on the edge of the Ross Ice Shelf in Antarctica. Usually, this is a place of profound silence and bone-cracking cold. But under the gaze of the Red King, the ice is weeping. The air temperature, which should be 40 degrees below zero, is hovering near the freezing point. The surface of the glacier is crisscrossed with rivers of meltwater, blue veins bleeding into the ocean. You can hear it, a constant, low-frequency groan as miles of ice shift and fracture. The great shelves, destabilized by the warming ocean waters eating them from below and the warm red air attacking them from above, begin to collapse. Icebergs the size of small countries calve into the sea with splashes that generate tsunamis. This is not the slow, generational climate change we have feared for decades. This is climate shock. The rapid injection of fresh water into the oceans disrupts the thermohaline circulation, the global conveyor belt of currents that regulates weather patterns from the equator to the poles. The Gulf Stream, the warm current that keeps Europe habitable, falters. The weather of the northern hemisphere becomes chaotic, swinging wildly between stagnant heat domes and sudden, violent freezes as the broken system tries to find a new balance. But the most terrifying manifestation of this new energy budget is found in the tropics. Hurricanes, typhoons, and cyclones are heat engines in their own right. They feed on warm ocean water, sucking up thermal energy and converting it into wind and rain. In our old world, hurricanes had a natural speed limit. They would churn up cold water from the deep, limiting their own growth, or they would hit land and starve. But in the binary world, the oceans are warmer. The red Jupiter provides a constant baseline of heat, raising the sea surface temperatures globally. The hurricane season is no longer a season. It is a permanent state of affairs. We begin to see storms that defy the Saffir-Simpson scale. Category 5 is no longer the ceiling. We witness the birth of the hypercane. These are storms with eyes 50 miles wide, walls of cloud reaching deep into the stratosphere, and winds stripping the bark off trees. They do not just damage cities, they scour the land. And because the atmosphere is churning with so much excess energy, the steering currents that guide these storms become unpredictable. A hypercane might stall over a coastline for days, dumping feet of rain, turning entire regions into inland seas. Imagine a storm that glows in the dark. At night, illuminated by the blood-red light of Jupiter, the swirling clouds of the hurricane would look like a bruise on the face of the earth. Lightning would flash within the red gloom, creating stroboscopic nightmares of violet and crimson. To live through such a storm would be to feel the wrath of a planet that has lost its equilibrium. The jet streams, those rivers of fast-moving air high in the atmosphere, would also be warped. These streams are driven by the temperature difference between the hot equator and the cold poles. As the poles warm up under the constant red light, that temperature difference decreases. The jet streams slow down. They become wavy, meandering across the continents in great, lazy loops. This leads to weather blocking. A heat wave in North America might not last for a few days. It might last for months, baking the soil until it turns to dust, creating dust bowls that span the continent. A deluge in Asia might not stop for weeks, drowning the rice paddies and washing away the infrastructure of nations. The predictability of the seasons vanishes. Farmers can no longer rely on the almanac. We return to a time of agricultural uncertainty, where feast and famine are dictated by the whims of a broken sky. And what of the oceans themselves? As the ice melts, the water rises. This is an inescapable fact of physics. The coastal cities of the world, New York, Tokyo, Shanghai, London, are built on the assumption of a stable sea level. But as the ice sheets of Antarctica and Greenland slide into the sea, accelerated by the second sun, the map of Earth begins to change. It is not a sudden wave, like in a disaster movie. It is a slow, relentless rising of the tide. The high tide today is an inch higher than yesterday. Next year, the streets are wet every full moon. The year after, the basements are flooded. Within a few decades, the coastline has moved inland by miles. We would become a species of refugees retreating from the water's edge, abandoning the concrete canyons of our ancestors to the encroaching salt. The ruins of our great metropolises would stand as skeletons in the surf, their glass towers reflecting the red light of Jupiter, monuments to a time when the sea stayed where it was told. Yet, life is tenacious. Evolution is a rapid responder when the pressure is high. In the oceans, the warming waters and the changed light spectrum would trigger a revolution in the plankton. Species that thrive in warmer, more acidic waters would explode in number. We might see vast blooms of red algae, red tides that are toxic to fish, but thrive under the red Jupiter. The ocean surface might turn a murky, biological purple, changing the very smell of the sea air. On land, animals would begin to migrate. Species that lived in the temperate zones would move toward the poles, chasing the cooler weather. We might see tropical birds nesting in what used to be Canada. We might see palm trees growing in the ruins of Scandinavian cities. The biosphere would remix itself, creating new ecosystems that are strange hybrids of the old world and the new. For humanity, this climate shift is the ultimate test of resilience. We are no longer fighting for supremacy over nature. We are fighting for alignment with it. Our architecture would change. We would stop building glass towers that trap heat and start building underground or into the sides of mountains, seeking shelter from the erratic weather and the constant light. Our agriculture would move indoors to vertical farms where we can control the light and temperature, protecting our food from the hypercanes and the droughts. We would become a more introverted species, hiding from the sky that has betrayed us. But there is a philosophical dimension to this tragedy. Standing on a hill, watching a red-lit storm roll over the horizon, one cannot help but feel a sense of awe. This is the earth acting as a living system. It is not passive rock and water. It is a dynamic, reactive entity. It is trying to distribute the heat, to find a way to survive the energy injection. The violence of the storms is the planet's way of sweating, of trying to cool itself down. We are witnessing the physiology of a world in fever. It reminds us that we are guests here. We do not own the thermostat. We are merely bacteria living on the skin of a giant, and the giant is waking up to a new reality. The beauty of the red earth is a melancholy one. It is the beauty of a sunset that stretches across the entire sky and never fades. It is the beauty of the auroras pushed down from the poles by the magnetic storm of the red Jupiter, dancing over the equator in sheets of green and red fire. Imagine walking through a tropical rainforest that is glowing with bioluminescence and auroral light, the air thick and hot, the sounds of strange new insects filling the air. It is an alien planet, yet it is our home. We have traveled to a new world without ever leaving the ground. We have been transported by the gravity of a failed star that finally succeeded. As we look toward the future of this binary Earth, we must ask, how long can this stability last? The weather is chaotic, yes, but is the orbit? We mentioned earlier that the planets are tugging at each other. With the atmosphere churning and the oceans rising, the Earth is changing its shape slightly, redistributing its mass. This changes its moment of inertia, its spin. The days might be getting longer or shorter. The wobble of the planet might be increasing. The very ground beneath our feet is not just being weathered by storms. It is being pulled by the tidal gravity of the Red King. The tectonic plates, lubricated by the rising sea levels and pulled by the dual gravity of Sun and Jupiter, might begin to slip. In the next chapter, we will go deeper, literally. We will explore the geological consequences of the binary system. We will look at the volcanoes of Earth, dormant for centuries, waking up in sympathy with the new gravitational rhythm. We will ask if the Ring of Fire is about to live up to its name in a way that threatens the very crust of our planet. The atmosphere is broken, the oceans are rising, and now the ground itself is preparing to betray us. We are walking a path of escalation, from the light in the sky, to the wind in the air, to the fire in the earth. The transformation is total, and as Theodore, the researcher, I must confess, there is a part of me that is terrified, and a part of me that cannot look away. The data is beautiful. The destruction is elegant. It is the dance of Shiva on a cosmic scale, destroying the world to recreate it. So, hold on to something solid. The storm outside is just the breathing of the new world. The real shaking is about to begin. The red Jupiter is not just a light and a heater. It is a heavy hand resting on the shoulder of the earth, and it is starting to squeeze. We often speak of terra firma, the solid earth. It is the one thing we trust implicitly. We build our houses on it, we pave roads over it, and we bury our dead within it, confident that it will hold them in its silent embrace forever. We assume that the ground beneath our feet is a static stage, a reliable platform upon which the drama of biology plays out. But geology teaches us a different truth. The earth is not solid rock all the way down. We are floating on thin rafts of crust, drifting atop a churning, molten mantle of magma. The only thing keeping the continents from sinking is the delicate balance of density and heat. And the only thing keeping the magma from bursting through is the pressure of the rock above it. In our binary solar system, that pressure is being manipulated by a ghost hand. The same gravitational tug-of-war that is pulling the oceans into new tides is also pulling on the rock itself. We are no longer living on a planet. We are living on a stress ball being squeezed by two giants. The phenomenon is known as tidal heating. We see it in our own solar system, in the tragic beauty of Jupiter's moon, Io. Io is a world of sulfur and fire, the most volcanically active body we know, because it is caught in a gravitational vice between Jupiter and the other Galilean moons. The immense gravity of Jupiter pulls on Io, bulging its surface up and down by hundreds of feet every single orbit. This constant flexing creates friction deep inside the moon. Rock rubs against rock, generating heat, enough heat to melt the interior and turn the surface into a pizza-like landscape of volcanoes. Now, imagine that dynamic applied to Earth. We are not as close to the red Jupiter as Io is to the old Jupiter, but the mass involved is far greater. We are caught between the Sun, with its 99% of the solar system's mass, and the red Jupiter with its new stellar heft. As Earth rotates, spinning between these two gravitational anchors. The crust is kneaded like dough. Hello, fellow observers of the shifting world. I am Theodore, the researcher. We have watched the sky turn red, we have watched the oceans rise, and now we are turning our attention downward to the fire that is waking up beneath our feet. We are exploring the total transformation of our home in a binary star system. If these journeys into the deep physics of our existence move you, if you find wonder in the terrifying power of nature, please subscribe to this channel. Your support is the bedrock of this community. Thank you for standing with us as the ground begins to shake. Now, listen closely. Can you hear the low rumble coming from the deep? The first sign of the geological awakening is not an eruption, but a vibration, a constant low-frequency hum that can be felt more than heard. It is the sound of the continental plates grinding against each other with renewed ferocity, the fault lines that crisscross our planet, the San Andreas in California, the North Anatolian in Turkey, the subduction zones of Japan, are sensitive systems. They store energy over centuries and release it in sudden, violent spasms. But with the added gravitational noise of the red Jupiter, the stick-slip mechanism of earthquakes is disrupted. The plates are being pulled apart and pushed together with a rhythm that matches the orbit of the new star. We would see a dramatic increase in seismic activity globally. Earthquakes would no longer be rare, terrifying events. They would be the background noise of existence. The big one would not be a singular prophecy for California. It would be a monthly occurrence across the globe. But the real terror lies in the ring of fire, this horseshoe-shaped belt of volcanoes and trenches bordering the Pacific Ocean is home to 1% of Earth's active volcanoes. Under the tidal stress of the binary system, the ring of fire would ignite in unison. Dormant giants, mountains that have slept for millennia, would clear their throats. Mount Rainier in Washington, Mount Fuji in Japan, Cotopaxi in Ecuador, they would all wake up. The night sky, already stained red by the star, would be choked with pillars of gray ash. The psychological impact of seeing the horizon lined with columns of smoke cannot be overstated. It would feel like the earth itself is rejecting us, pushing us off its back with plumes of fire and poison. This leads to a cruel paradox. We have a second sun in the sky, a heater that is warming the planet and melting the ice caps. But simultaneously, the awakened volcanoes are pumping millions of tons of sulfur dioxide and ash into the stratosphere. These particles act as a mirror, reflecting sunlight back into space. This is the mechanism of a volcanic winter. So, humanity would be trapped in a chaotic thermal war. On clear days, the heat of the red Jupiter and the sun would bake the land. But then, the volcanic veil would drift over, plunging the world into a sudden, deep freeze. We would not have global warming or global cooling. We would have thermal whiplash, a summer of fire followed by a winter of ash. The crops that managed to survive the confusing light cycle would now be choked by the falling gray snow of the volcanoes. And deep beneath the crust, in the liquid iron heart of our planet, another battle is being fought. The Earth's magnetic field is generated by the geodynamo, the swirling motion of molten iron in the outer core. This field is our shield. It deflects the solar wind, the stream of charged particles that flows from the sun. Without it, our atmosphere would be stripped away, and we would be bombarded by lethal radiation. But the core is also subject to the tidal forces of the new binary system. The kneading of the Earth affects the flow of the liquid iron. It introduces turbulence. The stable dipole field, the north and south poles we know, could become unstable. we might see a geomagnetic reversal, where the north and south poles flip, triggered by the external gravitational chaos. During a reversal, the magnetic field weakens significantly. It becomes a tangled mess of multiple poles. A compass would be useless, pointing to a north that might be in Bermuda or Siberia. But more importantly, the shield would develop holes. The combined solar wind of the sun and the red Jupiter, which, as a red dwarf, is particularly violent, would pour through these gaps. The auroras, which we previously imagined dancing over the equator, would now descend to the surface. We would see electrical discharges in the lower atmosphere, glowing ribbons of plasma reaching down to touch the mountaintops. The radiation levels on the surface would spike. Flying in an airplane would be lethal. Our satellite grid, the backbone of our communication, would be fried within days. We would be deaf, blind, and irradiated, clinging to a shaking rock. The geological transformation changes the very smell of the earth. The air would carry the tang of ozone from the electrical storms and the rotten egg smell of hydrogen sulfide from the volcanoes. The oceans, absorbing the volcanic gases, would become more acidic, accelerating the die-off of the coral reefs and the shellfish. The water itself would turn a strange, milky color in places, stained by the minerals leaching from the underwater vents. We are witnessing the reversion of Earth to a primordial state. This is what our planet looked like billions of years ago, in the Hadean Eon, before life calmed it down. We are traveling back in time, not through a wormhole, but through the brute force of gravity. Consider the psychological toll of the ground moving. We have an instinctual need for stability. When the earth shakes, it triggers a primal panic, a fight-or-flight response, with nowhere to run. In a world of constant tremors, that panic becomes chronic. The architecture of our civilization is not built for this. Our skyscrapers are designed to sway, but not forever. Our bridges, our tunnels, our dams, they are engineering marvels built for a static world. In the binary Earth, infrastructure becomes a trap. The great dams holding back reservoirs of water would be ticking time bombs. A single fissure in the concrete, widened by the relentless vibration, could unleash floods that wipe out valleys. Humanity would be forced to abandon the heavy concrete cities and return to lighter, more flexible ways of living. Or we would go deep. The safest place might be underground, ironically. If we could find geological strata that are relatively stable deep beneath the surface vibrations, we could build bunkers. But digging into a planet that is groaning with stress is a dangerous gamble. The heat from the interior is rising. The mines would be sweltering. We would be a civilization of moles, huddled in the dark, listening to the rock creak around us, waiting for the all-clear that never comes. The surface would be a realm of monsters, hypercanes, red knights, and rivers of lava. The underground would be a realm of fear. Yet, even here, amidst the sulfur and the shaking, there is a scientific majesty. We are seeing the connection between the celestial and the terrestrial. We often think of astronomy and geology as separate disciplines. One looks up, the other looks down. But the binary Earth proves they are one and the same. The movement of the stars dictates the movement of the continents. The gravity of the gas giant determines the eruption of the volcano. It is a holistic system, terrifyingly interconnected. The butterfly effect is real, but the butterfly is a star, and the hurricane is a supervolcano. This geological instability also brings minerals to the surface. The churning of the crust brings up rare earth elements, gold and diamonds from the mantle. A desperate humanity might find itself walking on riches it cannot eat. We might find veins of gold, exposed by a landslide, glittering in the red light, utterly useless in a world where a loaf of bread is worth more than a bar of bullion. The economy of the earth would collapse, replaced by the economy of survival. As we stand in the ashfall, covering our mouths with rags, watching the red sun set behind a smoking mountain, we realize that the planet is not dying. It is evolving. Earth has been a snowball, a hothouse, a water world, and a lava world before. It is indifferent to our comfort. It will survive the binary transition. The question is whether we can survive the Earth. Can we adapt to a world that tries to shake us off like fleas? Can we breathe the air that smells of brimstone? Can we find peace in a landscape that is constantly rewriting itself? In the next chapter, we will examine the biological consequences of this new, harsh environment. We have looked at the plants and the animals briefly, but now we must look at the microscopic world, the bacteria, the viruses, the fungi. In a warmer, wetter, more radioactive world, the unseen life might be the only winner. We will explore the rise of new plagues and the evolution of life forms that feed on the radiation of the red Jupiter. The monsters are not just in the sky or under the ground. They are in the water we drink and the air we breathe. The ground settles for a moment. The shaking stops. But the silence is heavy. It is the silence of a beast taking a breath before the next roar. We are learning the hard way that stability is an anomaly. Chaos is the default state of the universe. And we have just returned to the factory settings. This is Theodore, standing on the trembling crust of a new world. The journey is far from over. The fire is just beginning to burn. Keep your eyes open, travelers. The ash is falling, but the truth is still out there, waiting to be found in the rubble. When we look at the history of life on Earth, we tend to focus on the giants. We marvel at the dinosaurs, the thundering lizards that shook the ground. We study the megafauna of the Ice Age, the mammoths, and the saber-toothed cats. We tell stories of great kings and emperors, assuming that history is written by the large and the loud. But this is a vanity of scale. The true history of Earth is written in the microscopic code of DNA, by creatures so small they are invisible to the naked eye. For the first 3 billion years of our planet's existence, the only citizens were single-celled organisms. They terraformed the atmosphere, they invented photosynthesis, and they created the chemical foundation for everything that followed. We are merely the late-arriving skyscrapers built on their bacterial foundation. And now, in the sweltering, irradiated twilight of the binary solar system, the foundation is shifting. The giants are stumbling. The coastal cities are flooding, the crops are failing, and the mammals are hiding in caves. But the microscopic world is entering a golden age. We have turned the entire planet into a warm, wet, nutrient-rich incubator. We have created the perfect petri dish. The primary driver of this biological revolution is temperature. Biology is essentially chemistry, and chemistry speeds up when you add heat. For every 10 degrees Celsius rise in temperature, the metabolic rate of many cold-blooded organisms and microbes doubles. The red Jupiter, acting as a second sun, keeps the planetary temperature elevated. There are no more deep freezes to knock back the populations of insects or bacteria. The winter kill, nature's way of hitting the reset button on pest populations, is gone. This means that bacteria reproduce faster, mutations occur more frequently, and the evolutionary clock begins to tick at a frantic pace. In the stagnant, warm waters of the flooded coastlines, we would see a bloom of life unlike anything in human history. Hello, quiet observers of the unseen. I am Theodore, the researcher. We are peering through the microscope today, down into the drop of water that contains a universe of struggle and adaptation. We are exploring how the invisible kingdom reacts when the rules of the solar system are rewritten. If these journeys into the science of the hypothetical spark a sense of wonder in your mind, if you enjoy looking at the world from the atom up to the star, please subscribe to this channel. Your curiosity is the fuel for our exploration. Thank you for joining me in the laboratory of the imagination. Now, let us adjust the focus and look at the monsters swimming in the water. The first change we would notice is the color of the water. In our old world, healthy water was clear or blue, oxygenated by the churning of cool currents. But as the oceans warm and lose their ability to hold oxygen, warm water holds less gas than cold water. We would see the rise of hypoxic zones or dead zones. But they are only dead to fish, to anaerobic bacteria, organisms that do not need oxygen to survive. These zones are paradise. We might see the return of the purple sulfur bacteria, ancient organisms that thrived on Earth before the atmosphere had oxygen. They use hydrogen sulfide instead of water for photosynthesis, and they produce sulfur granules instead of oxygen. Under the red light of the new star, which favors their specific photosynthetic pigments, these bacteria would form vast, slimy mats on the surface of the lagoons and inland seas. The water would turn a bruised purple, and the air would smell of rotten eggs, the distinct tang of sulfur. It is the smell of the Permian extinction, the smell of a world reverting to a more primitive state. But it is not just the ancient bacteria that would thrive. The fungi, the great decomposers of the world, would find themselves in a land of plenty. With the chaotic weather killing off forests and the heat stressing animal populations, there is an abundance of dead organic matter to consume. Fungi love warmth and moisture, and the hypercanes and the endless humidity of the binary earth provide exactly that. We would see a fungal explosion. Molds of every color would colonize the damp ruins of the cities. But there is a specific type of fungus that we need to watch closely: the radiotrophic fungi. In the ruins of the Chernobyl nuclear reactor, scientists discovered a black fungus called Cryptococcus neoformans. It wasn't just surviving the intense radiation, it was eating it. This fungus uses melanin, the same pigment that tans human skin, to capture gamma radiation and convert it into chemical energy, much like plants use chlorophyll to capture sunlight. In our binary solar system, radiation levels are higher. The red Jupiter is a flare star, frequently bathing Earth in bursts of X-rays and ultraviolet light. The breakdown of the magnetic field allows more cosmic rays to reach the surface. In this environment, the black radiotrophic fungi would have a supreme evolutionary advantage. We might see the world turning black. The forests, once green, might be overtaken by dark, melanin-rich fungal structures that form symbiotic relationships with trees, or perhaps parasitic crusts that cover the rocks and the soil. A landscape draped in black velvet, feeding on the invisible fire of the stars. And then there are the viruses. Viruses are the ultimate opportunists. They sit on the edge of life, waiting for a host to replicate. In a world where animals are stressed, migrating, and crowding together in the remaining habitable zones, the barriers between species break down. This is the perfect recipe for zoonotic spillover. Viruses jumping from animals to humans. We have seen this with influenza and coronaviruses in our own history. But in the binary world, the the rate of interaction is multiplied. Bats, forced out of their caves by the heat or the changing magnetic fields, might roost in our attics. Rodents might swarm our food supplies. We would enter the age of pandemics. But these would not just be human diseases. They would be planetary plagues affecting crops, livestock, and wild animals simultaneously. The red fever, perhaps, a viral strain mutated by the high UV radiation sweeping through the population. This leads us to the concept of mutation. DNA is a fragile molecule. It is a long, twisted ladder of base pairs that carries the instructions for life. When high-energy particles, like those from a stellar flare, strike a DNA molecule, they can break the ladder. The cell tries to repair it, but in the haste of repair, mistakes are made. Letters are swapped. Instructions are garbled. Most of the time, these mutations are fatal to the cell. But sometimes, they create something new. In a high-radiation environment, the rate of mutation skyrockets. This is punctuated equilibrium on steroids. Evolution does not crawl, it sprints. We might see bacterial infections that develop antibiotic resistance in days rather than years. We might see weeds that evolve thicker, darker leaves to absorb the red light and block the UV. The biology of Earth becomes hyperactive, a frantic arms race of adaptation. For humanity, this microscopic siege would change our relationship with our own bodies. Our immune systems, evolved for a cleaner, colder world, would be overwhelmed. We might have to rely on genetic engineering to survive, editing our own code to produce more melanin, to repair DNA faster, to fight off the new superbugs. We might become a species of biohackers, merging our biology with technology just to maintain homeostasis. The hospitals of the future would not just treat injuries. They would be constant battlegrounds against the evolving microbial soup. Sterile environments would become the ultimate luxury. The wealthy would live in sealed, air-filtered domes, while the rest of humanity navigates the fungal jungles of the surface. Yet, there is a fascinating flip side to this biological chaos. The history of life is full of symbiosis. The mitochondria in our cells, the power plants that give us energy, were once free-living bacteria that were swallowed by larger cells eons ago. In the high-stress environment of the binary Earth, we might see new symbiotic relationships form. Perhaps humans would form a bond with the radiotrophic fungi, cultivating them on our skin or in our clothing to act as a living radiation shield. Perhaps we would genetically modify the purple sulfur bacteria to treat our waste and produce fuel. Life is inventive. It does not want to die. It wants to find a niche. And the binary Earth, for all its hostility, is full of energy. Consider the oceans again. As the pH drops and the water becomes acidic due to the volcanic carbon dioxide, the coral reefs dissolve. But in their place, we might see the rise of soft-bodied organisms, jellyfish, and slime molds that do not need calcium carbonate shells. The ocean would revert to the gelatinous era. Imagine a sea filled with massive, pulsing swarms of jellyfish, glowing with bioluminescence under the red star. It is a nightmare for a fisherman, but a paradise for a marine biologist studying resilience. The food chain shifts from fish-based to slime-based. We would have to learn to harvest protein from algae and jellyfish, changing our cuisine to match the new reality. The psychological impact of this invisible war is profound. In the old world, we feared the darkness because of the predators that might be hiding in it. In the new world, we fear the air, the water, and the touch of a surface. The threat is ubiquitous. It creates a society of high anxiety, of obsessive cleanliness, of rituals designed to ward off the unseen. but it also creates a society deeply in tune with biology. Every child would learn microbiology before they learn to read. The microscope would be as common a household appliance as the toaster. We would understand finally that we are not separate from nature. We are a porous vessel, constantly exchanging matter and energy with a living, evolving world. There is also the question of sleep. We mentioned the disruption of circadian rhythms in humans, but what about the microbiome in our guts? The trillions of bacteria living in our digestive systems also have clocks. They regulate our digestion, our mood, and our immune system based on the day-night cycle. When that cycle breaks, our internal ecosystem falls into chaos. We might see a rise in metabolic diseases, in depression, in chronic fatigue, all traced back to the confused bacteria in our stomachs. We are ecosystems within ecosystems, and when the macro world breaks, the micro world follows suit. But let us look for the hope in the petri dish. Evolution is a mechanism of improvement. It solves problems. Given enough time, and with the accelerated mutation rate, time is compressed. Life will solve the problem of the binary star. We might see the emergence of Homo radians, a human subspecies adapted to the new environment. Maybe their skin is darker, rich in eumelanin. Maybe their eyes are larger to capture the dim red light. Maybe their blood chemistry is different, containing natural antioxidants to scrub away radiation damage. The red Jupiter forces us to evolve. It pushes us out of our biological comfort zone. It is a harsh teacher, but it is effective. In the shadows of the fungal forests, strange new flowers bloom. They are not the delicate orchids of the past. They are thick, fleshy, perhaps carnivorous, trapping the explosion of insect life. They might bloom only during the red noon, opening petals that are black or deep maroon to soak up the heat. The bees that pollinate them might be larger, armored against the radiation. The sound of the forest changes from a gentle rustle to a wet, heavy hum of life reproducing at maximum speed. It is a jungle planet, a greenhouse world where the walls have been knocked down. And what of the possibility of new life? With the atmosphere changing, with lightning storms constantly synthesizing organic molecules, with the oceans turning into a chemical soup, could life begin again? Could we see a second Genesis? Simple, protocells forming in the volcanic mud pots, completely unrelated to the DNA lineage of Earth? It is unlikely in the short term, as existing life tends to eat any new competitors. But the binary Earth is a world of niches. If humanity and the higher animals were to fall, the stage would be set for something new to rise from the slime. The red Jupiter might not just be the destroyer of the old world. It might be the father of a strange, new lineage. As we wipe the condensation from our face shields and look out over the purple, bubbling ocean, we realize that the definition of monster is relative. To us, a world of slime molds and giant fungi is a horror show. But to the universe, it is just another expression of the tenacious energy of life. The atoms that make up the virus are the same atoms that make up the brain of a genius. It is all star stuff, rearranging itself to survive the fire. The microscopic world teaches us humility. We cannot bomb a virus. We cannot reason with a fungus. We can only adapt. We must become as fluid and resilient as the bacteria we share our planet with. In the next chapter, we will take this lesson of adaptation and apply it to our society. We will look at how human civilization, stripped of its stable climate and its health, attempts to reorganize itself. We will look at the cities of the future, the economies of survival, and the politics of a world where the sun never truly sets. We have looked at the rock, the water, and the cell. Now we must look at the mind and the tribe. The simulation hums with the data of 1,000,000,000,000 interactions. The petri dish is bubbling. The Red King watches, indifferent to the struggle, pouring his energy into the mix. And down here, in the mud and the blood, we are changing. We are becoming something else. Something stronger, or something that will be remembered only as a layer of sediment in the rock. The history of human civilization is a history of conquering the horizontal. We spread out. We crossed oceans to find new continents. We laid rails across vast plains to connect coasts. And we paved billions of miles of road to ensure that no corner of our world remained unreachable. We defined progress by our footprint, by how much of the Earth's surface we could claim, cultivate, and cover in concrete. But when the sky turns against you, the horizontal becomes a killing field. In the binary solar system we have simulated, the surface of the Earth is no longer a welcoming host. It is a hostile territory of hypercanes, searing radiation, and unpredictable volcanic winters. The era of the sprawling metropolis, the suburb, and the open highway is over. We are forced to remember a lesson learned by our ancestors who painted on cave walls. Safety is not found in the open. Safety is found in the deep. The trajectory of our species shifts from expansion to contraction, from the horizontal to the vertical. But this time, we are not building up toward the clouds. We are digging down into the crust. Imagine the skyline of New York or Shanghai 50 years after the ignition of Jupiter. The glass towers, once symbols of economic might, are now skeletons. Their windows have been blown out by the relentless winds of the superstorms, their foundations eroded by the rising acidic tides. They stand as jagged monuments to a climate that no longer exists, reflecting the bloody light of the Red King in their broken shards. No one lives in the penthouses anymore. The view is terrifying, and the radiation at that altitude is lethal. Instead, the life of the city has inverted. The streets are empty, save for the autonomous drones repairing the sea walls. The population has retreated into the undercity. We have repurposed the subway systems, the basements, and the deep foundations of the skyscrapers into a complex subterranean hive. We have become a species of geologists and engineers, valuing rock stability over ocean views. Hello, survivors of the surface. I am Theodore, the researcher. We are walking through the ruins of the old world to find the blueprint of the new one. We are asking what happens to the human animal when it is forced to retreat from the suns it orbits. If you find value in these explorations of resilience and adaptation, if you are curious about the future of our society in the face of cosmic change, please take a moment to subscribe to this channel. Your support builds the shelter in which we gather to tell these stories. Thank you for being here in the dark with me. Now, let us open the heavy blast doors and step into the city of the future. The architecture of the binary age is defined by density and defense. We would see the rise of the Earth scraper, an inverted skyscraper digging dozens of stories into the bedrock. These structures would be self-contained ecosystems, powered by geothermal energy, which is abundant thanks to the tidal kneading of the Earth, and protected by layers of lead and concrete. The air inside would be scrubbed of sulfur and volcanic ash, recycled endlessly through hydroponic gardens that act as the lungs of the building. The light would be artificial, a carefully calibrated spectrum designed to mimic the lost yellow sun of the old days, to keep our circadian rhythms from collapsing entirely. Walking through the corridors of an earth scraper, you would not hear the wind or the thunder. You would hear the hum of ventilation fans and the vibration of the geothermal turbines. It is a womb-like existence, safe but claustrophobic. But not everyone can live in the high-tech bunkers. The transition to a binary civilization would likely trigger the greatest inequality in human history. We would see a stark divide between the deep dwellers, the wealthy and essential personnel living in the secure, climate-controlled depths, and the surface scavengers, those left to fend for themselves in the retrofitted ruins of the old cities. The surface would become a shantytown of desperation, where people patch up the lower floors of abandoned buildings, shielding themselves with scrap metal and lead sheets, venturing out only during the brief lulls in the weather to scavenge for resources. This class divide would not be based on money, for money loses meaning when the banks are underwater. It would be based on access to filtered air, access to non-irradiated water, and access to the true light of the artificial suns. The economy of this world shifts from a consumer economy to a survival economy. In the 21st century, we value data, technology, and luxury goods. In the binary century, the most valuable commodities are fundamental. Fresh water becomes the new oil. With the glaciers melting into the salty oceans and the rain becoming acidic, pure, drinkable water is liquid gold. Wars would be fought not over borders or ideologies, but over aquifers. Nations that sit on top of deep, stable water tables would become the new superpowers. Canada, Russia, and Brazil might find themselves defending their water reserves against a desperate, thirsty world. The trade routes would be dangerous convoys of armored tankers moving water from the wet zones to the dry bunkers, constantly harried by the storms and the pirates of the wasteland. Agriculture, the backbone of civilization since the Neolithic Revolution, undergoes a total transformation. You cannot grow wheat in a field that is scorched by UV radiation one week and buried in volcanic ash the next. The rolling fields of the Midwest and the rice paddies of Asia are abandoned, turning into dust bowls or swamps. Farming moves indoors. We would see the rise of massive agri-towers, vertical farms illuminated by pink and purple LEDs, growing genetically modified crops that are calorie-dense and fast-growing. Meat production would move entirely to the lab. Raising cattle or pigs requires too much water and land. Instead, we would eat vat-grown protein, insect paste, and algae blocks. The culinary culture of humanity would be severed from the seasons. There are no strawberries in summer or pumpkins in fall. There is only the nutrient cycle of the hydroponic vat. We would eat to survive, not to celebrate. Politically, the nation-state might dissolve into the city-state. Maintaining a large, contiguous country is impossible when the infrastructure connecting it, the roads, the power lines, the internet cables, is constantly being destroyed by the binary chaos. The world would fracture into isolated pockets of civilization, each centered around a secure bunker complex or a defensible resource. These city-states would be highly authoritarian. In a survival situation, democracy is often seen as a luxury. Martial law would be the standard operating procedure. Resources would be rationed. Reproduction would be controlled to ensure the population does not exceed the capacity of the air scrubbers. It is a Spartan existence, driven by the ruthless logic of keeping the lights on. Yet, culture persists. Humans are meaning-making creatures. We cannot live by bread or algae paste alone. In the undercities, a new culture would emerge. We might see a reverence for the old world, with digital archives of blue skies and green forests becoming sacred texts. Children born in the deep would look at pictures of a beach and think it is a fantasy world, as distant and mythical as Narnia. Art would reflect the claustrophobia and the hope of the species. Music might become deeper, more bass-heavy, mimicking the rumble of the earth. Fashion would be purely functional, dominated by protective gear and radiation suits for the rare surface excursions. Religion, too, would mutate. The sky has always been the canvas of the gods. With two suns, the theology of earth would shift. We might see the rise of dualistic cults, worshipping the golden father, the sun, and the red sun, Jupiter. Some might view the red Jupiter as a punisher, a hell star sent to cleanse the earth of its sins. Others might view it as a tester, a force that strengthens the spirit through hardship. The red night would be a time of prayer and fear. The psychological weight of the constant red twilight would seep into our dreams. Psychologists would treat a new condition, chromophobia, a fear of the color red, or perhaps sky sickness, a panic attack triggered by open spaces. Education would focus entirely on the practical. The liberal arts might wither away, replaced by engineering, botany, geology, and medicine. Every citizen must be useful. A poet is a burden unless they can also fix a water pump. But in the quiet corners of the bunkers, the storytellers would still gather. They would whisper tales of the time when the moon was white, not red. They would tell stories of the quiet nights when the only light came from the distant stars and the air smelled of rain, not sulfur. These stories would be the most dangerous contraband, for they plant the seed of longing, the desire to reclaim the surface. And what of the surface itself? Is it truly abandoned? Perhaps not. There might be nomadic tribes who refuse the bunker life. They would be the walkers of the ash, adapted to the radiation, wearing scavenged hazard suits, moving constantly to stay ahead of the storms. They would be the masters of the new world, knowing the paths through the ruins, knowing which plants are safe to eat and which water sources are poisoned. They would look at the deep dwellers with pity, seeing them as prisoners in their own concrete tombs. The surface culture would be feral, violent, and free. A return to the hunter-gatherer roots, but hunting in the wreckage of the Anthropocene. There is also the question of time. Without the clear rising and setting of a single sun, time becomes fluid. The undercities would likely operate on a strictly enforced artificial clock, a 24-hour cycle maintained to keep sanity. But on the surface, time is dictated by the weather and the position of the Red King. The red days and the white days would blur together. History would stop being linear and start being cyclical, measured in survival cycles, in storms survived, in generations born and died in the dark. We must also consider the role of technology in this new dark age. While we might lose the global internet, local intranets would thrive. We would become a species of hackers, constantly repairing and jury-rigging the dying technology of the past. A working microchip factory would be more valuable than a diamond mine. We would scavenge the old data centers for parts. The cloud would no longer be a metaphor. It would be a physical server room buried deep in a mountain, guarded by soldiers, holding the sum total of human knowledge against the encroaching rot. In this binary crucible, the definition of human is stretched. Are we defined by our empathy or by our ability to endure? In the bunkers, faced with resource shortages, difficult choices would be made. The triage society would emerge. Who gets the medicine? The young or the skilled? Who gets to have children? the genetically pure or the wealthy, the ethics of the pre-binary world would crumble, replaced by a cold utilitarianism. We might lose our humanity in the process of saving our species, but there is a flicker of optimism. Humans are at their best when their backs are against the wall. The scientific advancements driven by the crisis could be staggering. We would master fusion energy finally, because we have no other choice. We would master genetic editing because we must. We would develop materials that are lighter and stronger than anything we have today. The pressure of the red Jupiter could squeeze us into a diamond of a civilization, hard, sharp, and brilliant. We might not be happy, but we would be capable. As we walk through the hydroponic gardens of the Undercity, smelling the sterile scent of nutrient solution and listening to the hum of the UV lamps, we realize that we have built a spaceship. We are living on Earth as if we are on Mars. We have created a closed-loop system, sealed off from the hostile environment. The binary solar system has inadvertently prepared us for the stars. If we can survive here, in the shadow of the Red King, we can survive anywhere. We have severed the umbilical cord that tied us to the biosphere. We are now a fully technological species, existing by the grace of our machines. The children of the bunker run past us, their skin pale, their eyes wide. They have never felt the wind. They have never seen a bird fly. To them, the sun is a light bulb, and the earth is a series of tunnels. They are the first generation of the new species. They do not mourn the lost world because they never knew it. They are the children of the binary system, and they are at home in the dark. But for us, the generation of the transition, the grief is a constant companion. We remember the smell of cut grass. We remember the sound of waves lapping gently against the shore, not crashing in acidic fury. We remember the blue sky, and in our dreams, we walk out of the airlock, take off our helmets, and breathe the air of a ghost world that is gone forever. The simulation flickers. The power grid of the Undercity fluctuates as a tremor shakes the foundations. The lights dim, then return. It is a reminder that even the bunkers are not safe forever. The Earth is restless. The red Jupiter is pulling. And we are just waiting for the next crisis. In the next chapter, we will ask the ultimate question of survival. If Earth is no longer a safe harbor, where do we go? We will look at the possibility of exodus. Can a civilization under siege build the arcs needed to leave the solar system? Or are we trapped here, destined to go down with the ship? We will look at the other planets, Mars, Titan, even the moons of the outer giants, and ask if there is a better home out there in the cold. The walls are closing in, the air is recycled, but the mind is free to roam, and our roaming takes us upward, past the blast doors, past the red clouds, to the silent, waiting void. The instinct to flee is older than the instinct to build. Long before our ancestors laid the first stones of Jericho or stacked the pyramids of Giza, they were wanderers. When the drought came, they walked toward the rain. When the fire came, they ran toward the river. Migration is the fundamental survival strategy of the biological machine. It is written into the genetic code of the wildebeest crossing the Serengeti and the monarch butterfly navigating a continent. But what do you do when there is nowhere left to run? What do you do when the drought covers the entire globe and the fire is falling from the sky? In the binary solar system we have simulated, the Earth has become a trap. The hypercanes scour the surface, the radiation cooks the air, and the ground shakes with the fury of a waking planet. The Undercities offer a temporary reprieve, a breathless existence in the dark. But they are not a solution. They are a tomb with a time lock. Eventually, the geothermal vents will clog, the water tables will run dry, or the psychological weight of living like termites will break the human spirit. The eyes of the survivors turn upward, past the red clouds, past the debris field of the shattered asteroid belt, to the other worlds that dance in the new light. We begin to ask the question that has haunted dreamers and astronomers for centuries. Is there another home out there? The concept of the habitable zone, or the Goldilocks zone, is the holy grail of exoplanet science. It is that narrow band of space around a star where the temperature is just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. For billions of years, Earth sat comfortably in the center of the sun's habitable zone, basking in the perfect amount of radiation. Mars sat on the freezing outer edge, a cold desert world. Venus sat on the boiling inner edge, a runaway greenhouse hellscape. But when we ignited Jupiter, we moved the goalposts. The red Jupiter is a heater. It radiates thermal energy into the solar system, effectively pushing the habitable zone outward. Earth, now caught between two fires, is being pushed out of the sweet spot and into the hot zone. But as Earth burns, the worlds further out are beginning to thaw. The binary transition might be a death sentence for us, but it could be a resurrection for our neighbors. Hello, fellow voyagers of the void. I am Theodore, the researcher. We are standing at the launch pad of the imagination, looking up at a sky that is hostile and full of promise. We are asking if humanity can leap from a burning ship to a lifeboat that is millions of miles away. If you find hope in these stories of cosmic endurance, if you believe that our destiny lies beyond the atmosphere, please subscribe to this channel. Your support is the thrust that lifts us out of the gravity well. Thank you for looking up with me. Now, let us turn our telescopes toward the red planet, which is looking less red and more green with every passing day. Mars has always been the mirror of our hopes. We look at its dry riverbeds and see a past that looks like Earth. We look at its polar ice caps and see a future that could support us. In our binary scenario, Mars is the primary beneficiary of the new thermal regime. Currently, Mars is a frozen desert with an average temperature of minus 80 degrees Fahrenheit. Its atmosphere is thin, composed mostly of carbon dioxide, unable to trap heat or block radiation. But introduce the red Jupiter. Mars orbits at an average distance of 140 million miles from the Sun. But at certain points in its orbit, it gets significantly closer to Jupiter than Earth does. The new star shines down on the Martian surface with an intensity that changes the atmospheric chemistry. The first thing to go is the dry ice, the frozen carbon dioxide at the poles. As the red Jupiter heats the planet, this dry ice sublimates, turning directly into gas. This thickens the atmosphere. A thicker atmosphere traps more heat. The greenhouse effect kicks in. It is a runaway effect, but unlike on Venus or Earth, where it leads to disaster, on Mars, it leads to rebirth. As the atmosphere thickens and the temperature climbs above the freezing point of water, the water ice buried deep in the Martian crust begins to melt. The ancient aquifers, sealed for billions of years, burst forth. We would see flash floods carving through the Valles Marineris, that grand canyon of the solar system. We would see the Hellas Basin filling up to become a circular sea. The dust storms that plague the planet would become rainstorms. Mars would transition from a red, dead world to a warm, wet, muddy world. It would not be a paradise immediately. The air would still be unbreathable carbon dioxide. The radiation would still be high because Mars lacks a strong magnetic field. But, compared to the hypercanes and volcanic winters of Earth, Mars looks like a sanctuary. It is a fixer-upper, but it has good bones. However, getting there is the problem. Space travel is difficult enough in a calm solar system. In a binary system, it is a nightmare. Remember the asteroid belt? The gravity of the new star has shattered the delicate resonance that kept those rocks in place. The space between Earth and Mars is no longer empty. It is a minefield. Millions of asteroids, ranging from pebbles to city killers, are drifting in chaotic orbits. A spaceship traveling to Mars would need shielding that does not currently exist, or it would need to be maneuverable enough to dodge bullets at 20,000 miles per hour. The Hohmann transfer orbit, the energy-efficient path we use to send probes to Mars today, would be suicide. We would need speed. We would need to get there fast, minimizing the time we are exposed to the debris field. This necessity forces a technological leap. Chemical rockets, the majestic columns of fire that took us to the moon, are too slow and too inefficient for the exodus. To move a civilization, or even a genetic seed bank, to Mars through a shooting gallery, we would need nuclear propulsion. We would likely revive projects like Project Orion, a design from the 1950s that proposed propelling a spacecraft by detonating small nuclear bombs behind it. It is a brute force method, messy and radioactive, but in a world that is already dying, the risks seem acceptable. We would see the construction of massive arc ships in Earth orbit. These would not be the sleek, white ships of science fiction. They would be ugly, industrial beasts, covered in thick plates of lead and ice for shielding, powered by the pulse of nuclear fire. The construction of these arcs would consume the last resources of the Earth. It would be the ultimate Manhattan Project. Every ounce of refined titanium, every microchip, every generator would be funneled into the orbital shipyards. This creates a terrible moral calculus on the surface. Who gets to go? If you can only build 10 ships, and each ship holds 10,000 people, that is 100,000 survivors out of 8 billion. The selection process would be the most contentious and violent event in human history. Would it be a lottery? A meritocracy where only doctors and engineers are chosen? Or would it be a plutocracy where the billionaires buy their tickets while the rest of the world burns? We would likely see wars fought over the launch codes. The launch pads would be fortresses, guarded by automated turrets against the desperate mobs trying to storm the rockets. The exodus would not be a unified triumph of humanity. It would be a lifeboat drill on the Titanic with guns. But let us assume we succeed. Let us assume a fleet of arcs breaks orbit, riding the nuclear shockwaves toward the red planet. The journey is terrifying. The ships are battered by dust and micrometeors. The radiation alarms are constantly blaring as the red Jupiter flares. But eventually, the rusty red marble, now turning a muddy brown-green, appears in the porthole. Landing on Mars is no longer the 7 minutes of terror through a thin atmosphere. The atmosphere is thicker now. Parachutes work better. Wings work better. The arcs glide down to the shores of the new Martian seas. The colonists step out, not into freedom, but into hard labor. They must build domes. They must plant the genetically modified lichen that will slowly convert the carbon dioxide into oxygen. They are not living on a new Earth. They are terraforming a planet in real time, racing against the clock of their own life support systems. But Mars is not the only option. The habitable zone has moved, but how far? If the red Jupiter is hot enough, the sweet spot might extend even further out, to the realm of the gas giants. Specifically, to the jewel of Saturn, Titan. Titan is the only moon in the solar system with a thick atmosphere, denser than Earth's. It is rich in organic compounds, raining hydrocarbons into lakes of liquid methane. Currently, it is freezing cold, minus 290 degrees Fahrenheit. But under the influence of the red Jupiter, which is much closer to Saturn than the Sun is, Titan warms up. The methane cycle intensifies. The water ice that makes up the bedrock of Titan begins to soften. If Titan warms enough, it becomes a strange biological paradox. The organic chemistry there is complex, the building blocks of life waiting for a spark. The heat of the binary system provides that spark. We might not be able to live on the surface of Titan without breathing apparatus. The atmosphere is mostly nitrogen and methane, with no oxygen. But the pressure is comfortable. You could walk on Titan without a pressure suit, just a warm coat and an oxygen mask. The low gravity means humans could strap wings to their arms and fly like birds through the dense orange haze. It is a dream world, a place of orange skies and dark, oily seas. For a humanity fleeing a dying Earth, Titan offers something Mars does not, an abundance of fuel. The entire moon is made of hydrocarbons. Energy would never be a problem. We would burn the sky to keep warm. There is a profound irony in moving to the outer solar system. We are moving closer to the very thing that destroyed our home. To live on Mars or Titan is to live in the court of the Red King. The new star would dominate the sky, a constant reminder of the power that forced us to migrate. On Titan, the red Jupiter would be a small but brilliant disk, far brighter than the distant, shrunken sun. We would be children of the new star, warmed by its light, evolved by its radiation. The cultural memory of Earth would fade into myth. The blue planet would just be a bright star in the evening sky, a lost paradise that we discuss in hushed tones around the methane heaters. However, the exodus is not just about physical relocation. It is about the preservation of the species. We would take with us the frozen zoo, vials containing the sperm and eggs of every animal species we could save. We would take the digital archives of the Library of Congress, the music of Bach and the Beatles, the blueprints of the pyramids. We are the custodians of Earth's memory. If the Ark ships fail, the story of 4 billion years of evolution ends. This responsibility weighs heavy on the colonists. They are not just refugees. They are the backup drive for a planet. Every child born on Mars is a victory against the silence of the universe. But let us return to those left behind. The vast majority of humanity does not make it to the arks. They watch the contrails of the nuclear rockets fade into the upper atmosphere, knowing they have been abandoned. This moment, the great departure, creates a schism in the human soul. The people of Earth must find a way to make peace with their fate. The undercities become permanent. The struggle becomes local. The dream of the stars is gone, taken by the chosen few. This might lead to a strange kind of nihilistic peace, or a descent into total savagery. Or perhaps the earthbound humans evolve in their own way. They merge with the machines. They embrace the fungal symbiosis we discussed earlier. They become the dark humans, adapted to the deep, while the star humans on Mars become frail and dependent on technology. If, thousands of years later, the Martians return to Earth, would they even recognize their cousins? Or would they see them as monsters, aliens on their own homeworld? The Exodus also forces us to rethink our place in the universe. We used to think we were the center of it, or at least the center of our solar system's attention. But the binary event proves that the universe is indifferent to us. We are fleas jumping off a burning dog. We are not conquering space. We are fleeing into it. This humility might be the most important thing we carry to the stars. We are not masters of nature. We are survivors of it. This shift in perspective could create a wiser, more cautious civilization, one that treats its planetary environment with reverence, knowing how easily it can be taken away. On Mars, terraforming would be done with extreme care. We would not pollute the air we just spent a century creating. We would not poison the water we just melted. The trauma of losing Earth would be the foundational myth of the Martian society, a never again etched into the collective consciousness. There is also the question of the other gas giants, Saturn, Uranus, Neptune. They too are affected by the new gravitational and thermal landscape. Their ring systems, delicate structures of ice and dust, might be disrupted by the gravity of the red Jupiter. The rings of Saturn might ripple and warp, or eventually dissolve, raining down into the planet. The great storms on Neptune, driven by internal heat, would be supercharged by the external heat. The entire solar system is waking up. It is becoming a more energetic, more violent, more dynamic place. We are moving from a clockwork universe of predictable orbits to a thermodynamic universe of flow and chaos. As the Ark ship Hope 1 coasts through the vacuum, passing the orbit of the moon, now a scorched gray rock stripped of its romance, the captain looks back. The Earth is a crescent, but it is not the blue marble of the Apollo photos. It is a swirling marble of gray clouds, brown dust, and angry red oceans. It looks sick. It looks angry. And behind it, rising like a second dawn, is the red Jupiter, the architect of this destruction. It is a sight that breaks the heart, but also hardens the resolve. We cannot go back. The door is closed. The only way is forward, into the dark, toward the small red dot of Mars that hangs in the window like a drop of blood. The journey is long. The radiation shields are degrading. The hydroponics are failing. But in the cargo hold, a baby cries. It is the sound of the future, a future that will be written in red dust, under orange skies, by a species that refused to die when its sun betrayed it. We are the dandelion seeds, blown by the wind of the apocalypse, looking for a patch of soil where we can grow again. And what of the universe beyond? Does this happen often? Are there other civilizations out there, refugees from binary ignitions, floating in the void between stars? Perhaps the galaxy is full of wanderers, species that have been kicked out of their nests by the violent mechanics of stellar evolution. Perhaps we will meet them, the Federation of the Homeless, united by the loss of their worlds. We are joining a cosmic club of survivors. The silence of space is absolute. The roar of the nuclear drive is a vibration in the hull, not a sound in the air. We are alone, but we are together. And as Earth fades to a bright star, indistinguishable from Venus or Mercury, we say goodbye. Goodbye to the oceans. Goodbye to the forests. Goodbye to the graves of our ancestors. We carry you in our memory. We carry you in our DNA. Theodore, the researcher, signing off from the bridge of the imagination. We have left the cradle. The nursery is burning, and the universe is waiting to see if we can walk on our own 2 feet. We measure our lives in heartbeats, in the rhythmic expansion and contraction of a muscle that never rests until the end. We measure our history in generations, the passing of the torch from parent to child, a chain of memory that stretches back to the first fires of the savannah. But the universe measures time in the vibration of atoms and the death of stars. To the cosmos, the entire saga of humanity, from the first stone tool to the launch of the nuclear arcs, is a fleeting spark, a momentary flash of complexity in the deep, cold silence. As the last contrails of the Exodus ships fade from the upper atmosphere of Earth, dispersing into the radioactive winds, the planet does not mourn. The Earth is a rock. It is a ball of iron and silica, wrapped in a thin veil of gas. It has no memory of the creatures that crawled upon its skin, bored tunnels into its crust, and then fled when the temperature rose. It simply continues to spin. But the spin is changing. The orbit is changing. In the binary solar system, nothing is static. We have entered the era of the three-body problem, a gravitational dance between the Sun, the Earth, and the red Jupiter that is mathematically chaotic and destined to end in violence. The silence on the surface is absolute, save for the howling of the wind. The great cities, those monuments to human ego, are being dismantled by the chemistry of the New World. The acidic rain, born from the volcanic sulfur and the oceanic evaporation, eats into the concrete. The steel rebar inside the skyscrapers rusts and expands, cracking the stone from within. Glass turns to dust under the relentless bombardment of UV radiation from the flaring Red King. Within a few thousand years, a blink of an eye in geological terms, the horizontal lines of our civilization will be erased. New York, London, Tokyo, they will be reduced to strange geometric hills covered in the black radiotrophic moss we discussed earlier. The artifacts of our existence, the cars, the computers, the plastic bottles, will be buried under layers of ash and mud, waiting for a future archaeologist who may never come. Hello, watchers of the deep time. I am Theodore, the researcher. We are moving the clock forward, spinning the dial past the centuries of human struggle, to look at the destiny of the Earth itself. We are asking what happens to a planet when it is caught between two jealous lovers. If you find peace in the vast impersonal scales of cosmic history, if you are humbled by the endurance of matter over mind, please subscribe to this channel. Join us as we stand witness to the eons. Your presence here ensures that even if the world is forgotten, the story is not. Thank you. Now, let us sit on the mountaintop of the future and watch the celestial mechanics unfold. The stability of the solar system, which allowed life to flourish for 4 billion years, was a result of the sun's overwhelming dominance. It was the conductor, and the planets were the obedient orchestra. But with the ignition of Jupiter, we have introduced a second conductor playing a different tempo. The gravitational interaction between the Sun and the red Jupiter creates resonances, points in space where the gravitational pulls align and amplify each other. Earth, orbiting between them, passes through these resonances like a ship hitting a series of rogue waves. Its orbit, once nearly circular, begins to stretch into an ellipse. This eccentricity is the enemy of life. In a highly elliptical orbit, Earth swings close to the Sun, boiling the oceans even further, and then swings far out, past the orbit of Mars, into the freezing dark. We would experience super seasons that last for decades. A summer where the oceans evaporate and the atmosphere turns to steam. A winter where the atmosphere freezes and falls as nitrogen snow. This freeze-thaw cycle is a sterilization event. It scrubs the surface clean, all but the most hardy extremophiles, the bacteria living deep in the crust, the only true inheritors of the planet. But gravity is not just about stretching. It is about ejection. Computer simulations of three-body systems show that the lightest object is often the one that gets kicked out. Earth is the feather in this scenario. As the millions of years roll by, the tug of the red Jupiter becomes more pronounced. There is a non-zero probability that Earth could be flung out of the solar system entirely. Imagine the terror and the beauty of that moment. The gravitational slingshot. Earth passes too close to the red Jupiter, gaining speed, stealing momentum from the giant. It accelerates past the escape velocity of the Sun. It breaks the invisible chains of gravity. The Sun and the red Jupiter recede into the distance, becoming two bright stars in a sea of darkness. Earth becomes a rogue planet, a wanderer in the interstellar void. On a rogue Earth, the atmosphere would freeze solid. The oceans would turn into ice sheets, miles thick, preserving whatever lies beneath them in a perfect, eternal cryostasis. The planet would drift through the galaxy for billions of years, a silent mausoleum of human history drifting between the stars. It is a lonely fate, but perhaps a poetic one. We would become a message in a bottle, cast into the cosmic ocean, waiting to be caught by the gravity of another star system eons from now. However, there is another possibility, one that is perhaps even more dramatic. Instead of being ejected, Earth could be captured. The red Jupiter, with its immense mass and its own retinue of captured asteroids, is a gravitational net. It is possible that through a complex interaction of tidal forces, Earth could be pulled out of its solar orbit and into an orbit around the red Jupiter itself. Earth would become a moon of the new star. This would change everything. We would transition from being a planet of the Sun to being a satellite of a red dwarf. Life as a moon of a red dwarf is a strange existence. We would likely become tidally locked, just as the Galilean moons were. One side of Earth would face the red Jupiter forever, baked in perpetual crimson daylight. The other side would face the cold void, locked in eternal night. The twilight zone, the thin strip of land between the day and night sides, would be the only habitable region. Here, the sun would sit forever on the horizon, casting long shadows that never move. The winds would be ferocious, driven by the massive temperature difference between the hot and cold sides of the planet. It would be a world of constant storms, a Terminator civilization clinging to the edge of the light. But it would be stable. The red Jupiter burns its fuel slowly, while our original sun has a lifespan of about 10 billion years. A red dwarf can burn for trillions of years. By becoming a moon of Jupiter, Earth effectively buys itself an immortality policy. Long after the sun has died, Earth would still be warm, huddled close to the embers of the Red King. Let us pause to consider the irony of the sun's fate. We worship the sun as the giver of life, the eternal fire. But the sun is dying. It is a middle-aged star, burning through its hydrogen reserves at a voracious rate. In about 5 billion years, regardless of whether Jupiter ignited or not, the sun will run out of fuel. Its core will collapse, and its outer layers will expand. It will become a red giant. It will swell to a monstrous size, swallowing Mercury and Venus. In our original timeline, it would likely swallow Earth too, or at least scorch it into a cinder. But in our binary scenario, the dynamics are different. If Earth has been stolen by Jupiter or ejected into the void, it might escape the sun's death throes. It might watch from a safe distance as its original parent swells, turns red, and eventually puffs off its outer layers to form a beautiful planetary nebula, a ghost of gas glowing in the dark. The red Jupiter, however, is playing a different game. Red dwarfs are the tortoises of the stellar race. They are fully convective, meaning they mix their fuel constantly, using every atom of hydrogen available. They do not bloat into giants. They simply burn, steady, and dim for a length of time that defies comprehension. 1,000,000,000,000 years is nothing to a red dwarf. When the sun is nothing but a cold, dead, white dwarf, a diamond the size of Earth slowly fading into blackness, the red Jupiter will still be shining. It will be the last light in the solar system. If humanity, or whatever we evolve into, survives on Mars or Titan or on the captured Earth moon, they will eventually forget the sun. They will remember it only as a bright companion that once existed, a myth of a golden age before the universe grew old. Their entire existence will be defined by the red light. This shift in stellar dominance forces us to rethink the concept of failure. We call Jupiter a failed star because it didn't ignite on its own. But in the long run, the massive, bright stars like our sun are the failures. They burn too hot, too fast. They are the rock stars of the galaxy, living fast and dying young, leaving behind chaos. The red dwarfs are the successful ones. They are the survivors. They are the most common stars in the universe for a reason. They play the long game. By igniting Jupiter, we have aligned our solar system with the dominant mode of existence in the cosmos. We have joined the majority. Let us return to the surface of the abandoned Earth, assuming it remains in a chaotic solar orbit for now. The biological evolution we discussed in the previous chapter continues, but it takes strange turns. With the ozone layer shredded by the red Jupiter's flares, the surface is bathed in UV radiation. Life must go underground or armor itself. We might see the rise of lithivores, organisms that eat rock, or perhaps the oceans, shielded by water, become the final refuge. The whales and dolphins, intelligent mammals, might find themselves the new masters of the planet. But the ocean chemistry is changing. As the carbon dioxide levels rise, the water becomes acidic. The shells of creatures dissolve. The marine ecosystem simplifies. It becomes a world of jellyfish and squid, soft-bodied intelligence navigating the gloomy, red-lit depths. They would have no concept of the sky, no concept of the stars. Their universe would be a boundless, warm, acidic fluid, pulsed by the rhythmic gravity of the two suns. And what of the ruins? The human footprint is stubborn. Even after millions of years, traces would remain. The plastics we created are effectively immortal. A layer of techno-fossil plastic would exist in the geological strata, a thin, synthetic line marking the Anthropocene. The nuclear waste we buried deep in mountains would still be radioactive, a silent warning to any future species that digs too deep. The gold in our vaults, the titanium in our hip replacements, these would survive the erosion. A future alien xenogeologist landing on this chaotic world would find these anomalies. They would piece together the story of a species that rose quickly, burned brightly, and then vanished when the sky changed. They would see the launch pads of the arcs, the scorched concrete pointing toward Mars, and they would know they escaped. Or at least they tried. The atmosphere of Earth would eventually change its composition. Without the vast forests to pump oxygen, and with the volcanic activity pumping CO2, the oxygen levels would drop. The sky would turn from a hazy red to a sickly yellow-brown, the color of a bruised peach. It would be a heavy, suffocating atmosphere, similar to the Archean Earth. This deoxygenation would be the final nail in the coffin for any surviving mammals. The age of the warm-blooded beast would end. The age of the slow, the cold-blooded, and the microscopic would return. The earth circles back to its beginning, ashes to ashes, slime to slime. But let us cast our minds even further. to the time of the galactic collision. In about 4 billion years, the Milky Way is scheduled to collide with the Andromeda Galaxy. This is a cosmic event of unimaginable scale. Two spiral galaxies containing trillions of stars will pass through each other. In a single star solar system, this event is largely visual. The chances of stellar collision are low, but in a binary system, the gravitational cross-section is larger. The disruption of the galactic merger could strip the red Jupiter away from the Sun entirely. We could be divorced. The red Jupiter, taking its moons, and perhaps the captured Earth with it, could be flung into the depths of Andromeda. The Sun, with its inner planets, could stay in the Milky Way remnant. Our solar system would be bisected, the family broken apart. Imagine the view from the surface of Earth during this era. The sky is not just filled with red light, it is filled with the distorted, swirling arms of a colliding galaxy. Star formation is triggered on a massive scale. The night sky is ablaze with new blue supergiants exploding as supernovae. It is a fireworks display that lasts for millions of years, and in the middle of it, our little red Jupiter chugs along, a calm boat in a stormy ocean, carrying the corpse of Earth into a new galactic home. It is a migration on a scale that makes the Mars exodus look like a walk to the mailbox. The beauty of the long goodbye is that it emphasizes the resilience of matter. The atoms that make up your body right now, the calcium in your bones and the iron in your blood, will be part of this future. They will be in the dust of the ruined cities, in the water of the acidic ocean, or perhaps in the hull of an arc ship drifting between stars. We are not just observers of this story. We are the raw material of it. We are the stuff that will eventually be swallowed by the red Jupiter, or ejected into the void, or merged with Andromeda. We are eternal, in the sense that our particles will witness the end of time. This perspective creates a strange kind of comfort. It removes the pressure of the now, the anxieties of our daily lives, the bills, the politics, the arguments, seem so small when placed against the backdrop of a trillion-year red star. We are transient passengers on a rock that is just passing through. The rock itself is just passing through. Even the stars are just passing through. The only permanent thing is the laws of physics, the silent, invisible scaffold that holds it all together. As Theodore, the researcher, I find myself looking at the red Jupiter in our simulation, not with fear, but with a kind of affection. It is a companion. It is a watcher. It is a reminder that the universe is not finished. It is still building, still destroying, still experimenting. We might be the victims of this particular experiment, but that does not make it any less magnificent. We are the sacrifice on the altar of cosmic evolution. So, let the red light shine, let the oceans rise, let the continents drift. It is all part of the dance. A dance that began in the Big Bang and will continue until the last photon fades into the heat death of the universe. We are lucky to have heard the music for a little while. In the next chapter, we will leave the Earth behind completely. We will travel to the new home of humanity, to the terraformed Mars and the hydrocarbon seas of Titan. We will see what kind of society rises from the ashes of the Exodus. We will ask if we learned our lesson, or if we are destined to repeat the mistakes of the past on a new world. We will explore the Martian dream and the reality of living under the Red King's rule in a foreign sky. The simulation pauses here, hovering over the silent, red-lit ruins of a planet that was once blue. It is a graveyard, yes, but every graveyard is also a garden waiting for the next season of growth. The red Jupiter is the gardener, and the planting season has just begun. The dust of Mars has always been red, oxidized iron rust that speaks of a dead, dry past. But as the ramp of the Ark ship Hope 1 lowers onto the Chrysoplanitia, the dust is wet. It is a thick, muddy slurry churning under the landing struts. The sky above is not the pale salmon pink of the rover photos from the 21st century. It is a heavy, bruised purple, choked with clouds of water vapor and carbon dioxide that are trapping the heat of the new binary star system. And dominating the eastern horizon, rising above the rim of a distant crater, is the architect of this wet miracle, the red Jupiter. From here, it is smaller than it appeared from Earth, but it is still the brightest object in the sky, a searing ruby eye that stares down at the refugees with an intensity that casts sharp, bloody shadows. We have arrived. We have crossed the shooting gallery of the asteroid belt. We have endured the radiation storms, and we have landed on a world that is waking up. But we are not stepping into a garden. We are stepping into a construction site. The terraforming of Mars is not a gentle process of planting trees. It is a violent industrial war against entropy, powered by the same star that destroyed our home. Hello, citizens of the new frontier. I am Theodore, the researcher. We have left the smoking ruins of Earth behind us, crossing the void to stand on the soil of our second chance. We are exploring the reality of life on a terraformed Mars and a warmed Titan, asking what kind of society rises from the ashes of a planetary exodus. If you find inspiration in the resilience of the human spirit, if you are curious about the mechanics of building a world from scratch, please subscribe to this channel. Your support is the oxygen in our tanks. Thank you for walking the red mud with me. Now, put on your helmet. The air is thick, but it is not yet yours to breathe. The Martian dream, sold to the people of Earth during the frantic years of the Exodus, was one of freedom. It was a vision of a new start, a blank canvas where we could correct the mistakes of the past. But the reality of Mars under the Red King is a military meritocracy. You do not get to be free until the airlock is sealed. The society that emerges here is defined by the iron law of pressure. On Earth, a mistake might cost you your job or your comfort. On Mars, a mistake kills everyone in the dome. If a technician fails to scrub the CO2 filter, the sector suffocates. If a farmer introduces a pathogen to the algae vats, the colony starves. This creates a culture of extreme discipline, surveillance, and communal responsibility. Privacy is a relic of the old world. In the cramped modular habitats buried beneath the Martian regolith to shield against the lingering radiation, everyone knows everyone's business. We have become a hive mind, not by choice, but by necessity. The terraforming process is the central religion of this new world. We are not just living on Mars, we are feeding it. The red Jupiter provides the heat, melting the polar caps and releasing vast amounts of carbon dioxide and water. But the atmosphere is still toxic. The colonists are essentially biological machines working to convert the sky. We would see vast fields of atmospheric processors, nuclear-powered towers that suck in the Martian air, strip out the toxins, and pump out oxygen. But the real work is done by the lichen. Genetically modified super lichen, designed to eat rock and excrete breathable air, paints the landscape in shades of vibrant, alien orange and black, colors chosen to absorb the red light of Jupiter. Walking on the surface in a pressure suit, you would see a world that looks like a coral reef exposed to the air. It is a biological crust, living and breathing, slowly digesting the planet to make it hospitable for us. But Mars is just the suburb of the new solar system. The true frontier, the Wild West of the binary age, is Titan. Orbiting Saturn, Titan has always been a strange cousin to the terrestrial planets. It is a moon, yet it has an atmosphere thicker than Earth's. It has liquid on its surface, but it is methane, not water. Under the influence of the red Jupiter, Titan transforms from a cryogenic freezer into a hydrocarbon tropic. The temperature rises to a point where water ice acts as rock, but the methane cycle accelerates into a frenzy. It rains gasoline on Titan. Great thunderstorms of hydrocarbons roll across the sky, dumping fuel into lakes the size of the Great Lakes on Earth. For the human colonies on Titan, life is radically different from the regimented existence on Mars. Mars is a struggle for resources. Titan is a struggle against abundance. Energy is free. You can literally scoop up the lake water and burn it. This abundance creates a different kind of society, a high-energy industrial powerhouse. The Titan colonies would become the factory floor of the solar system. They would manufacture the plastics, the carbon fiber, the synthetic fuels needed to keep the fleet of arc ships flying. The cities of Titan would be floating platforms, oil rigs the size of Manhattan, drifting on the methane seas. The people here, the Titans, would be rougher, bolder, living in a world of constant storms and orange fog. They would wear winged suits, using the low gravity and dense atmosphere to glide between the towers, human birds in a smoggy paradise. However, the relationship between Mars and Titan would likely be fraught with tension. Mars has the food from its greenhouses and the military discipline. Titan has the fuel and the industrial capacity. They are dependent on each other, yet separated by 1 billion miles of vacuum. We might see the rise of a Cold War in the outer solar system, a trade dispute that threatens to turn hot. The red Jupiter, hanging between them, watches impartially. It provides the energy that powers both worlds, but it also provides the radiation that makes the space between them deadly. Travel between the colonies would be rare, undertaken only by the brave void haulers, truckers of the cosmos, who navigate the debris fields and the magnetic storms to deliver algae to Titan and methane to Mars. Let us look deeper into the psychology of the children of the red star. The first generation born on Mars has never seen a blue sky. They have never felt rain that wasn't acidic or cold. To them, the sun is a myth, a small, overly bright star that appears sometimes in the morning. Their true sun is the red Jupiter. This shifts their biological and emotional baseline. Studies on Earth showed that red light affects the human mind differently than white light. It can increase alertness, but also anxiety. The Martian population might be chronically high-strung, a species of insomniacs constantly bathed in the crimson glow. Their art would be dark, intense, obsessed with shadow and flame. Their eyes might evolve or be genetically modified to be more sensitive to the infrared spectrum, allowing them to see heat signatures in the cold Martian night. There is also the ghost of Earth. How do the colonists remember the home they fled? Is it a lost Eden, a paradise destroyed by human hubris? Or is it a warning, a planet of fools who refuse to adapt? The history books used in the Martian schools would likely be heavily edited. They would emphasize the failures of the Earth governments, the slowness of the response, the selfishness of the pre-Exodus culture. They would paint the old humanity as weak and short-sighted, contrasting it with the new humanity of Mars, tough, rational, and survivor-focused. The memory of Earth becomes a tool of social control. Do not be like them, the teachers would say, pointing to the bright speck in the evening sky. Do not take your air for granted. Do not waste a drop of water, or you will end up like the ghosts on the third rock. But ghosts have a way of haunting the living. On quiet nights, when the wind howls through the canyons of Valles Marineris, some colonists might look up at Earth through telescopes. They would see a world of swirling clouds and gray oceans, and they might wonder, is anyone still down there? Did the dark humans survive in the bunkers? Are they looking back at us? This curiosity could spawn a movement, a reclaimer faction that wants to send a mission back to Earth. Not to live, but to salvage. To recover the Mona Lisa from the buried Louvre. To find the seed banks of Svalbard. To see if the whales still sing in the acidic oceans. This would be heresy to the ruling council, who view Earth as a forbidden zone, a radioactive graveyard best left undisturbed. The adaptation to the new gravity is another physical reality. Mars has only 38% of Earth's gravity. Titan has even less, about 14%. Children born here would grow taller, thinner, their bones less dense. If a Martian were to try to stand on Earth, they would be crushed by their own weight. We are becoming physically incompatible with our homeworld. We are speciation in action. We are no longer Homo sapiens. We are Homo martis and Homo titanus. This biological divergence makes the idea of returning home physically impossible without an exoskeleton. We are chained to our new worlds by the weakness of our own skeletons. And what of the Red King itself? Living under a red dwarf star is dangerous. We mentioned the flares. On Earth, the atmosphere and magnetic field protected us. On Mars, which has no global magnetic field, the protection must be artificial. The colonies would be surrounded by massive superconducting rings, generating localized magnetic shields to deflect the stellar wind. When a flare hits, the alarms would scream, and everyone would retreat to the deepest shelters, the storm cellars. The auroras would explode overhead, not just at the poles, but enveloping the entire planet in a cage of violet fire. These flare days would be times of terror, but also of community. Huddled together in the dark, waiting for the radiation storm to pass, the colonists would tell stories, sing songs, and reaffirm their bond. The red Jupiter is a harsh god, but it forces its subjects to care for one another. In the greenhouses of Mars, the plants are weird. They are not the green, leafy vegetables of Earth. They are black, purple, and deep red, bred to absorb the specific spectrum of the red Jupiter. A salad on Mars would look like a bowl of dark, alien foliage. The taste would be different, too. More bitter, perhaps, due to the different mineral content of the regolith. We would lose the taste of sweetness, which requires the high-energy sugars produced by strong sunlight. The Martian diet is savory, earthy, and functional. The concept of luxury food, a chocolate bar, a coffee bean, would be the ultimate status symbol, synthesized in high-tech labs at enormous cost. As the centuries pass, the terraforming begins to take hold. The air pressure on Mars rises enough that you can walk outside without a pressure suit, just an oxygen mask and warm clothes. The green Mars, or rather black Mars due to the dark plants, becomes a reality. Rivers of meltwater flow through the canyons. A primitive ecosystem of lichens, mosses, and insects begins to function on its own. Humanity relaxes its grip slightly. The domes are opened. We build cities on the surface, towers of glass and steel that reflect the red dawn. We start to feel like we belong here. We stop looking back at Earth with longing and start looking at it with pity. But the universe has a sense of humor. Just as we get comfortable, just as we think we have mastered the binary system, the red Jupiter throws a curveball. Red dwarfs are stable for long periods, but they can exhibit super flares that are thousands of times more powerful than anything our sun ever produced. One day, the Red King might burp. A coronal mass ejection of apocalyptic size could slam into Mars, stripping away a chunk of the hard-won atmosphere, frying the electronics, and sterilizing the surface crops. It would be a reminder. You are guests. You are never safe. The struggle is eternal. This constant proximity to disaster creates a philosophy of existential stoicism. The Martians and Titans do not fear death the way Earthlings did. They accept it as a constant companion. They celebrate life with a fierce intensity because they know how fragile it is. Their poetry is about the beauty of the shield holding, the miracle of a sprout growing in the rust, the warmth of a fellow human in the cold. It is a culture stripped of vanity, focused on the essence of existence. In the next chapter, we will jump forward in time, past the centuries of settlement, to the deep future. We will look at the descendants of these colonists after 1,000,000 years of evolution under the red star. We will see them not as humans, but as something else, creatures perfectly adapted to the twilight, to the radiation, to the low gravity. We will ask if they have forgotten their origins entirely, or if the myth of the blue star still lingers in their folklore. We will also look at the fate of the Earth, now a feral world, and ask if life there has taken a different, stranger path. The timeline expands, the biology diverges, and the red Jupiter burns on, the eternal watcher of the drama it created. We stand on the edge of the Chrysalis Sea, watching the waves of meltwater lap against the red sand. The sky is dark, the stars are few, but the Red King is bright. We are alive. We are different. And we are home. Time is a river that erodes everything, washing away mountains, memories, and even the biological definitions of what it means to be human. When we speak of humanity, we usually picture a specific shape: 2 arms, 2 legs, a hairless skin, and a brain obsessed with patterns. We assume this form is the pinnacle of evolution, the finished product. But evolution has no finished products. It only has works in progress. In our simulation of the binary solar system, we have now spun the clock forward, not by centuries, but by 1,000,000 years. The red Jupiter, once a terrifying newcomer, is now the ancient, unshakable god of the sky. It has burned with a steady crimson light for 10,000 centuries, outlasting the civilizations that first named it. The original sun is still there, but it is distant, a white dwarf in the cultural consciousness, if not yet in physical reality, a ghost of a brighter, harsher past. Under the influence of this deep time and the distinct pressures of 3 different worlds, Mars, Titan, and the abandoned Earth, the single trunk of the human family tree has split into 3 divergent branches. We are no longer one species. We are a trinity of strangers, sharing a solar system, but separated by the abyss of biology. The dust of Mars has settled. The terraforming projects of the Exodus era have reached a stable equilibrium, but it is not the Earth-like paradise the ancestors dreamed of. It is a dark violet world. The vegetation that covers the planet is jet black, evolved to absorb the weak red photons of the dwarf star with maximum efficiency. Walking through these silent, swaying forests of black fern trees are the children of Mars, or Homo Martis. They are striking, elegant, and utterly alien to our 21st century eyes. Evolution in low gravity, 38% of Earth's, has elongated their skeletons. They stand 7 or 8 feet tall, impossibly slender, moving with a fluid, floating grace that would look like underwater ballet to us. Their bones are hollow and lattice-like, like those of birds, sufficient for the light gravity, but fragile. A fall on Earth would shatter them. On Mars, they drift. Hello, travelers of the eons. I am Theodore, the researcher. We have arrived at the destination of our long evolutionary journey. We are looking at the faces of our descendants and trying to find the recognition in their eyes. If you find a sense of awe in the plasticity of life, if you wonder what form intelligence might take in the deep future, please subscribe to this channel. Your support allows us to project these visions onto the screen of the imagination. Thank you for enduring the time jump with me. Now, look closely at the figure emerging from the black forest. Do you recognize your kin? The most arresting feature of the Homo martis is not their height, but their eyes. Under the dim, red light of Jupiter, the human eye has evolved to become a massive light bucket. Their eyes are twice the size of ours, dominating their thin faces. They lack the white sclera. Instead, the eye is entirely dark, a pool of reflective tapetum lucidum that catches every stray photon. They see the world in a spectrum we cannot imagine, perceiving the infrared heat signatures of living things as vibrant auras against the cold rock. Their skin is a deep, matte slate gray, rich in melanin, to protect against the flares of the Red King. Culturally, they are a species of silence and telepathy, not magic, but technology. They have integrated the noosphere, a wireless neural network, directly into their biology. They speak rarely, preferring to share thoughts and data packets instantly. They are the high elves of the solar system, intellectual, detached, living in crystal spires that sing in the Martian wind, viewing the violent history of their species as a primitive, bloody myth. Far across the vacuum, in the orange haze of Saturn's moon, a different experiment has played out. Titan is a world of cold hydrocarbons and thick atmosphere. The gravity here is even lower, but the need for insulation is paramount. The Homo titanus have not grown tall and slender. They have grown compact and robust. They are the dwarves of this cosmic fantasy. Standing perhaps 4 feet tall, they are barrel-chested, possessing massive lung capacity to process the nitrogen-methane air which they breathe through sophisticated biological filters, or perhaps cyborg implants that have become hereditary. Their skin is covered in a fine, dense down, a fur-like layer that traps heat. In the thick, soupy atmosphere of Titan, they do not walk so much as they glide. They wear membranes of synthetic fabric stretching from wrist to ankle, allowing them to catch the updrafts of the thermal vents. A city on Titan is a spectacle of aerial acrobatics, with thousands of these stout, furry humanoids swooping between the floating refineries. The Titans are the industrialists, the engineers, the masters of matter. While the Martians meditate on abstract mathematics in their spires, the Titans are wielding the hull of a starship. Their culture is loud, boisterous, and tribal. They worship the great machine, the planetary engine that keeps their life support running. They view the Martians as effete and fragile, lost in dreams. The Martians view the Titans as crude and dirty, obsessed with fire and oil. They trade because they must. Titan sends volatile fuels to Mars. Mars sends biological tech to Titan, but they do not mix. A Titan on Mars would suffocate and overheat. A Martian on Titan would freeze and be crushed by the atmospheric pressure. They are biologically incompatible. The dream of a unified humanity is dead, replaced by the reality of speciation. But what of the cradle? What of the abandoned Earth? For 1,000,000 years, the Earth has been a feral world, drifting in its chaotic orbit, baked by the red Jupiter and frozen by the distance. But life, as we know, is stubborn. The humans who were left behind, the rejected, did not all die. The surface became uninhabitable for the baseline human, yes. But the undercities and the deep oceans provided a refuge for a forced evolution that was brutal and rapid. The descendants of Earth are the Homo chthonius, the people of the deep. Imagine venturing into a lava tube deep beneath the ruins of the Rocky Mountains. In the pitch blackness, warm and humid from the geothermal vents, you hear a clicking sound. It is echolocation. The Earth humans have lost their sight almost entirely. Their eyes are vestigial milky orbs, useless in the dark. Instead, their ears have enlarged, becoming bat-like and sensitive to the slightest vibration in the rock. Their skin is pale, translucent, revealing the network of veins beneath. They are small, crouching creatures, moving on all fours with a scuttling speed that is terrifying. They are not savages. They are masters of their domain. They farm fungi in the dark. They harvest the blind fish of the underground rivers. And they have a rich oral history chanted in a language of clicks and whistles. There might also be a second branch on Earth, the aquatic humans. In the flooded ruins of the coastlines where the water is warm and acidic, some populations might have adapted to a semi-aquatic life. The mer-humans, possessing webbed fingers and toes, a larger spleen to hold oxygenated blood for long dives, and a layer of blubber to protect against the chemical burns of the ocean. They live in the skeletons of the submerged skyscrapers, diving for the shellfish that have taken over the ecosystem. To the Martians and Titans, these Earth creatures are not human. They are cryptids, monsters to be studied or avoided. Occasionally, the Martians launch an expedition to Earth. It is an archaeological mission, a pilgrimage to the old world. But it is also a safari. The Martian scientists, encased in their sleek, pressurized exosuits, walk through the jungles of giant fungi that now cover the surface. They scan the ruins with their sensors, finding the technofossils, the layers of compressed plastic and concrete that mark the Anthropocene. They find the rusted remains of a car, a statue of a forgotten leader, a plastic doll. They look at these objects with a detached curiosity, like we look at the stone tools of Homo erectus. They do not feel a connection. They do not weep for the lost civilization. To them, Earth is a cautionary tale, a planet that failed to transcend its biology. During one of these expeditions, a Martian researcher might encounter a Homo chthonius emerging from a vent. It is a moment of profound cosmic irony. The descendant of the astronaut meets the descendant of the abandoned. They stare at each other, one with giant black eyes seeing heat, the other with blind white eyes hearing heartbeats. Do they recognize the shared DNA? Do they sense the common ancestor who once walked under a yellow sun and checked a smartphone? Likely not. The divergence is too great. The Martian sees a subterranean animal. The Earthling senses a strange, vibrating god encased in a shell. One might fire a stun gun. The other might flee into the dark. The reunion of the human family is a moment of fear, not love. This speciation raises a difficult philosophical question. What is the destiny of intelligence? We assume that intelligence leads to unity, to a Star Trek future where everyone works together. But biology suggests that intelligence leads to niche adaptation. We adapt to our environments until we can no longer understand each other. The binary solar system has become a laboratory of diversity. It has proven that human is a fluid concept, a temporary container for consciousness. There is a myth that persists among the Homo martis, hidden in their encrypted data streams. It is the myth of the blue star. They say that in the time before the Red King reigned, there was a star that shone with the color of wisdom, a blue-white light that revealed the true nature of things. They say that under this star, the ancestors lived in a paradise of water and green, where they could fly without wings and breathe without machines. It is a distortion of history, a romanticized memory of Earth before the ignition. The Titans have a different myth. They speak of the cold Iron Age, a time of hardship that forged their strength, a time when their ancestors built the arks with their bare hands to escape a burning world. Myths are how species explain their suffering. The Martians explain their fragility by dreaming of a lost paradise. The Titans explain their toil by glorifying a history of struggle. But the red Jupiter does not care about myths. It continues to burn. Its flares continue to scour the surfaces of the worlds. It is the engine that drives this entire drama. Without the red Jupiter, Mars would be dead dust, and Titan would be a frozen ball of ice. The monster star is the mother of this new diversity. It is the reason life persists at all. In a strange way, the failed star has succeeded beyond measure. It has cultivated a garden of intelligence far more complex than the monoculture of the old Earth. As we look at the solar system from a distance, seeing the ships moving between the red and orange worlds, seeing the feral Earth drifting in the dark, we realize that survival is not about staying the same. Survival is about becoming something else. We are not the end of the story. We are the bridge. The humans of the 21st century, you and I, are the transitional form between the ape and the Martian. We are the raw material that the universe is kneading into new shapes. The tragedy is that the branches of the tree can no longer touch. A Martian cannot hold the hand of a Titan. Their biologies are incompatible. A Titan cannot embrace an Earthling. The pressure difference would kill them. We are alone together, separated by the very adaptations that saved us. It is a lonely kind of victory, and yet there is a unity in the struggle. All three species, the tall, the stout, and the blind, are fighting the same battle against entropy. They are all waking up, eating, reproducing, and trying to make sense of the cosmos. They all look up at the red Jupiter with a mix of reverence and fear. The star is the common denominator. It is the totem around which the tribe has fractured, but it is still the center of the dance. In the final chapter of our journey, we will take the ultimate step. We will go to the end of time itself. We will watch as the red Jupiter finally begins to die. We will watch the collision of the galaxies. We will ask what happens when the heat finally runs out, and the descendants of humanity face the big freeze. We will see if they can escape again, or if this solar system is their final resting place. The story of life is a story of escaping traps, but is there a trap that cannot be escaped? The simulation is running hot. The timeline is stretching to the breaking point. The Red King is old, but he is not dead yet, and his children are watching, waiting for the next sign from the sky. There is a word that humans use to comfort themselves against the terror of the finite: forever. We pledge our love forever. We build monuments to last forever. We imagine our souls existing forever. But in the physical universe, forever is a forbidden concept. Thermodynamics allows for long durations, for spans of time that would crush the human mind like an insect under a boot. But it does not allow for eternity. Every battery runs dry. Every clock winds down. Every fire consumes its fuel. And now, in the final chapter of our simulation, we have reached the limit of the Red King's endurance. We have traveled forward not just millions of years, but trillions. The era of the stars, the stelliferous era, is drawing to a close. The universe is growing old. The vibrant, chaotic tapestry of galaxies has stretched thin, pushed apart by the relentless expansion of dark energy. The night sky is no longer a canvas of diamonds. It is a profound, suffocating void, punctuated only by the rare, dying embers of the longest-lived stars. And here, in the cold heart of the merged Milkomeda galaxy, the ancient wreck of the Milky Way and Andromeda, our red Jupiter is preparing to sing its final song. The star that saved humanity, the failed star that we ignited in a moment of desperate hubris, has outlived nearly everything else, while the massive blue giants burned out in mere millions of years, and the yellow suns, like our original Sol, faded into white dwarfs after 10 billion years. The red Jupiter has been a miser. It has sipped its hydrogen fuel with extreme caution, circulating it from the core to the surface, wasting nothing. It has nurtured the civilizations of Mars and Titan for an epoch that makes the entire history of Earth look like a single heartbeat. But now, the hydrogen is gone. The tank is empty. The fusion engine that held back the crushing weight of gravity is sputtering. The Red King is dying. Hello, the last witnesses of the light. I am Theodore, the researcher. We have walked the entire path together, from the first ignition of the gas giant to the scattering of the human seed, and now to the twilight of time itself. We are standing at the edge of the universe's history, watching the lights go out, one by one. If this journey through the grandest scales of existence has moved you, if you find a strange peace in accepting the impermanence of all things, please take a moment to subscribe to this channel. Your presence here, at the end of all things, makes the darkness less lonely. Thank you for staying until the very end. Now pull your cloak tight. The big freeze is coming. To understand the death of the red Jupiter, we must understand the unique life cycle of a red dwarf. Unlike our sun, which will swell into an angry red giant and devour its children before collapsing, a red dwarf does not go out with a bang. It goes out with a shift in color. As the hydrogen runs out, the star begins to compress. The helium that is built up in the core over trillions of years is squeezed tighter and tighter. This compression generates heat. Paradoxically, as the star dies, it gets hotter on its surface. It does not expand. It shrinks. The dull red glow that has bathed the solar system for eons begins to shift up the spectrum. It turns orange, then yellow. Then, in its final glorious phase, it turns a brilliant, piercing blue. The astronomers of the future, if they still possess eyes to see, call this the blue dwarf phase. It is a theoretical stage of stellar evolution that no human in the 21st century ever saw, because the universe is not old enough yet for any red dwarf to have reached it. But in our simulation, we are there. Imagine the psychological impact on the post-human species living on Mars. For 1 trillion years, their sky has been red. Their eyes are evolved for red. Their plants are black to absorb red. Their entire mythology, their religion, their concept of goodness is tied to the red light. And now the god is changing. The light is becoming harsh, ultraviolet, and blindingly white-blue. It is as if the sky has suddenly opened up to reveal a terrifying new reality. The vegetation on Mars would scorch. The delicate black fern trees would wither under the intense UV radiation of the blue dwarf. The atmosphere, which had been carefully maintained for eons, would be stripped away by the increased solar wind of the contracting star. The blue swan song of Jupiter is not a gentle lullaby. It is a sterilization event. The post-humans, the Homo martis and Homo titanus, would be forced to retreat once again. They would have to go back underground, back into the dark, hiding from the very light that signals the end of their world. They would realize that the stability they enjoyed for trillions of years was just a long summer. And now, the cosmic winter has arrived. But where can they go? In the previous chapters, we spoke of migration. We moved from Earth to Mars, from Mars to Titan. But now, there is nowhere left to run. The universe is dead. Most other stars have already burned out, leaving behind only black holes, neutron stars, and cold white dwarfs. The galaxies have moved so far apart that they are no longer visible. There are no fresh pastures. The resource scarcity is absolute. The second law of thermodynamics, entropy, has finally caught up with us. The disorder of the system is maximizing. The energy available to do work is approaching zero. In this ultimate crisis, the civilization of the solar system would likely turn inward, not into bunkers, but into the digital realm. The physical universe has become hostile and resource poor, but the virtual universe, running on the last dregs of energy, offers infinite space. We might see the construction of a matryoshka brain around the dying red Jupiter. This is a megastructure, a swarm of computers that completely encloses the star, capturing every single photon of energy it emits. The physical bodies of the Martians and Titans would be discarded. Their consciousnesses would be uploaded into the machine. They would become beings of pure software, living in a simulated paradise, powered by the last light of the blue dwarf. Inside the simulation, they could recreate the Earth of the 21st century. They could recreate the red Mars of the early settlement era. They could live millions of lifetimes in seconds, experiencing a subjective eternity while the objective universe outside freezes to death. It is the ultimate retreat. We abandon the rock and the flesh to become memory and light. The red Jupiter becomes the battery for a heaven of our own making. But even a matryoshka brain cannot last forever. Eventually, the blue dwarf will exhaust its nuclear fuel completely. The fusion stops. The light flickers and dies. The star cools down to become a white dwarf, a ball of degenerate electron matter, the size of Earth, but with the mass of a star. It is a diamond in the sky, glowing with residual heat, but generating no new energy. The matryoshka brain would have to power down. One by one, the servers would shut off. The simulations would end. The digital civilizations would go to sleep, perhaps archiving themselves in a final, super-dense crystal, a message in a bottle left on the tombstone of the solar system. And what of the physical remains? The planets, Mars, Titan, the feral Earth, would continue to orbit the dead white dwarf, but they would be frozen solid. The atmosphere of Mars would freeze into nitrogen ice on the surface. The oceans of Titan would become solid methane rock. The Earth, if it is still there, would be a ball of white ice, indistinguishable from a snowball. The silence would be absolute. No wind, no tectonic movement, no heartbeat, just the silent clockwork motion of cold rocks circling a cold corpse. This is the heat death, or the big freeze. It is the destiny of the universe. It sounds depressing, I know. We want the story to end with a triumph, with a new beginning. But science tells us that the story ends in quiet. However, there is a beauty in this quiet. The violence of the universe is over. The collisions, the explosions, the burning. It is all done. The universe has spent its fury. It enters a state of perfect crystalline rest. It is a peace that surpasses all understanding. Let us zoom out one last time. Let us look at the Milkomeda galaxy. It is a galaxy of ghosts. It is populated by billions of white dwarfs, neutron stars, and black holes. It is a graveyard of light. But in the darkness, there is still gravity. The black holes will eventually evaporate via Hawking radiation, a process that takes googles of years. The white dwarfs will cool until they become black dwarfs, invisible balls of cold matter. The protons themselves might decay. The universe will become a sea of photons and leptons, a thin soup of particles stretching into infinity. But in the middle of this vast desolation, there is a specific coordinate, a specific white dwarf that used to be a red dwarf, which used to be a gas giant named Jupiter. And orbiting it are the frozen husks of the worlds that gave birth to us. The atoms in those frozen rocks are the same atoms that were in your blood. The calcium in the bones of the Homo martis buried in the ice is the same calcium that was forged in the explosions of the first stars. We are not separate from this ending. We are the structure of it. And perhaps, just perhaps, this is not the true end. Some physicists theorize that the universe is cyclical, that in the infinite stretches of time, quantum fluctuations could trigger a new Big Bang, that from the ashes of the old universe, a new vacuum bubble could form, inflating into a new cosmos with new laws of physics. Maybe in that new universe, a gas giant will form. Maybe a species of curious bipeds will look at it and wonder, what if we ignited it? The cycle of curiosity is the only thing that might be more persistent than entropy. As Theodore, the researcher, I find it hard to say goodbye to this simulation. We have lived 1 trillion years in 10 chapters. We have played God, and we have paid the price. We have learned that every action has a consequence that ripples through eternity. Igniting Jupiter gave us a second life, a second chance, but it did not save us from the ultimate fate of the cosmos. Nothing can save us from that. But the journey was magnificent, was it not? We saw the double sunset on the beach of a transformed Earth. We saw the ice of Europa boil into steam. We saw the rise of the fungal forests and the black lichens. We saw the launch of the arcs, trailing nuclear fire against a purple sky. We saw the tall, slender Martians dreaming in their spires, and the stout Titans flying through the methane rain. We saw the blue dwarf ignite and the digital heaven rise. We witnessed the full potential of matter to organize itself into meaning. The screen of our imagination is fading to black now. The red Jupiter is gone. The blue Jupiter is gone. There is only the dark. But do not be afraid of the dark. The dark is where we came from, and the dark is where we go. It is the womb and the tomb. It is the natural state of things. The light was just a brief, beautiful interruption. So, tonight, when you look up at the real Jupiter in our real sky, that bright, white, wandering star, give it a nod of respect. It is sleeping. It is saving its energy. It is watching over us, a potential sun that never was, a guardian of the dark. And be thankful for our own yellow sun. It is burning itself to death to keep you warm right now. Feel its heat on your skin tomorrow morning, and know that it is a gift, a limited time offer from a universe that is generous but finite. Thank you for traveling the timeline with me. Thank you for asking, what if? The simulation is ended. The data is archived. The researcher is signing off. Good night, my friends, and may you find your own light in the coming dark.